What's going on, everybody? Johnny Bandon, the networking guru, and we're going to continue on our Security Plus crash course by going over Domain 2. So in this video, hopefully we finish all of Domain 2. We don't have to split it into a couple parts. Let's just jump right into it. Okay, so Domain 2. So we're going to start off Domain 2 by going over comparing and contrasting common threat actors and motivations. Okay, so our objectives. We're going to go over the different types of threat actors. And what we're talking about here is, when someone's hacking our network, who are they sponsored by? Are they self-sponsored? Is it organized crime? When we get exploited, who's behind it? We know there's some technical person there, some hacker, some red team, but who is actually behind it? We're going to go over the different attributes of actors, and as we describe the threat actors, we're also going to talk about their motivations. So we won't have slides dedicated to motivations. It'll be part of us teaching about these threat actors. So let's get started. So the first type of threat actor we're going to talk about is a nation state. So this, in real world, these are advanced persistent threats. So advanced persistent threats, or APT teams, are well documented. They're well known in the world of cybersecurity, and they're always sponsored by what we call a nation state, just a foreign adversary's government. Now I'm talking from the perspective of an American, right? So when we look at APT teams, I go on the MITRE attack matrix, which we'll learn about eventually in this course, but it's just a database, a matrix, if you will, of all the different types of attacks that have happened, TTPs and the APTs behind them, the advanced persistent threat teams behind them, and they're always sponsored by an adversary: Russia, China, Iran, North Korea. So nation states, though, just in the terms of Security Plus, to pass the exam, these are actors that are sponsored or directed by national governments, and they engage in cyber espionage, sabotage, or warfare, and it's in the interest of their nation, right? To advance national interests. The Sandworm team, they're a team out of Russia. Now, again, real world, I try to give you real world. When we look at these APT teams, sometimes they don't claim to be from a certain government, or government won't claim them, but we know that, okay, it's Russian sponsored. Even if their government doesn't come out and say, yes, we sponsored that team, they're like, oh, we're just hackers, but they're a nation state, okay? They're the most advanced. They can live on your network. They have the most tools, the most resources. They have the most time, and they're well funded. So their motivation is political, military, economic, or just a strategic advantage. This is the year 2025. It's April 25th, actually, the time of this recording. What major conflicts are happening in the world? Russia and Ukraine. Before Russian tanks and soldiers, conscripts, entered Ukraine, what did they attack first? Critical infrastructure. They did that through cybersecurity, cyber espionage, right? So that's a nation state advancing their national interests. Another threat actor that used to be called the script kiddie, and we'll still call it that, but CompTIA exam objectives say it's called an unskilled attacker. These are just persons, a group, or just a single individual that gets pre-written software or scripts to launch attacks. It's just, hey, I downloaded Kali Linux. Let me try to run this like frame flooding attack. Ooh, I watched a YouTube video on how to do a DNS poisoning attack or change the host file of a Windows machine. So I'm a hacker now, right? Their motivation is curiosity, desire for recognition, or some sort of malicious intent just to see if they can hack. Here's our guy here. He's asking Kali Linux if he's a hacker because he installed it on a VM. It's a step, right? Okay, and then a hacktivist. So a hacktivist is somebody who uses they're motivated politically, and they're kind of like social activists. They try to promote a political agenda or what they believe is morally correct. They try to promote social change or ideological beliefs through hacking. Well, something that always gets talked about, like in Security Plus exam, is they deface websites or whatever the case may be. They're morally motivated, and that's their type of hacking, to attack what they consider morally wrong, and that's like governments or big organizations. Like right here, unionize Amazon warehouses. Imagine if that was on Amazon.com. Come on, Jeff Bezos would freak out. But that would be a hacktivist if someone was able to do that. Okay, an insider threat. So these are individuals within the organization. Now this can be malicious in nature. This could be someone, a corporation trying to commit corporate espionage by getting someone from inside the organization, give them a competitive edge by releasing information. This could be a nation state attack as well. Now, what I mean by that, not to be confused with nation state threat actor, an adversarial government could try to pay like a soldier or an airman or someone in our government to release secrets. So their motivation is financial gain. It could be for revenge. Maybe they don't like the US government anymore and they want to expose them, right? Could be for recognition. So ideological reasons. And sometimes it's not malicious at all. An insider threat could just be an individual from within the organization that accidentally exposes data or information, right? It doesn't have to actually be malicious in nature. Now, when we think of insider threats and we get like security awareness training on our day to day, that's what we're supposed to look out for. Like, this person's acting a little strange. They recently got divorced. They're in financial debt. They've been talking really bad about our government or about the corporation. So maybe that's a sign that they could eventually turn into an insider threat, right? But their motivation, again, is financial gain, revenge, espionage, or ideological reasons. Then organized crime. So these are groups engaging in illegal activities for profit, and it's through cyber. We talk about organized crime in the context of cybersecurity through some cyber means. Now, this isn't like, what you see in the TV shows or movies where it's a group of hackers in a warehouse connected to somehow an untracked ISP connection or a geosynchronous satellite. They'll never find us. Most of the time, this is like factories dedicated to bot attacks, like somewhere in a third world country. When you get those smishing attempts on your phone, those SMS texts that are attacks, like they're trying to get your credentials to get you to press a link and they say, hey, you have tolls that are unpaid, you click it, or there's a package at your door, click this Amazon link and sign in. That's organized crime. There's whole factories, like human factories built to do this, to commit fraud against you. Their motivation is always financial gain too. In some way, they're trying to get your data, get your information to make money. Shadow IT. So this is something that is not in nature malicious at all. It just refers to users on your enterprise not understanding what they can and can't do with technology, and maybe they bring in unapproved IT. So for an example, when you onboard someone, so they come into the organization, you go and put them through HR, and then it's the IT team's turn to onboard. So you get them their accounts, you have them sign documents like acceptable use policies, you have them go through some cyber training, you tell them, hey, this is what you can and can't use, whatever the case may be, right? But they feel like they can't get work done efficiently. They've used this in their last company, they use this at home, like Google Drive, Dropbox, whatever the case may be, and they want to be more efficient. Or maybe they're just ignorant, they just don't know they can't, install Steam on their work laptop. Why not? When I'm not working on my breaks, I can just go on Steam. People take cigarette breaks. Why can't I take a gaming break, right? And it's just ignorance, right? So they're not explicitly trying to harm the organization, but they do it without approval. They try to use IT systems, software, without approval. So their motivations, efficiency, lack of available resources. Maybe they feel like they don't have the necessary resource to get their job done, or they're just ignorant of the policy. Okay, attributes of actors. So this is just saying like, are they internal or external? What's the certain attributes we can assign to these attackers? So internal, are they a hacktivist that works within an organization? Are they an insider threat? And then external, are they a nation state, advanced persistent threat team attacking us from the outside, a hacktivist attacking us from the outside, right? So are they internal, external? Resources and funding. So their resources and funding determine how successful they will be. So obviously like nation state actors and organized crime groups will typically have the most resources and funding. So they're going to have more sophisticated attacks, more time, and they're going to be more efficient, and they're just trained. Where unskilled attackers, they have hacktivists in here, but hacktivists sometimes can be well-funded. They can be self-funded even, but they may have limited resources. So they may not be as sophisticated as your other threat actors. Okay, and then levels of sophistication and capability. So the different levels. So obviously nation state and organized crimes are going to have higher sophistication. Unskilled attackers have the lowest. Insider threats, it's kind of hard to judge their sophistication, right? Because an insider threat could be a senior developer that's about to get laid off and puts in a logic bomb, or it could be someone from accounting that hates the company and, gives away like accounting information thinking it's going to mess with our IT systems, whatever the case may be, right? Insider threats, sophistication varies. But one thing they do have an advantage of is they're inside. They understand how the systems may or may not work. They may even have elevated access depending on their position, right? If they work in IT. And then hacktivists, it just ranges, right? It ranges between a lone actor or a whole group dedicated to it, right? That may be self-funded. Okay, so that was domain 2.1. Let's move on to domain 2.2. Okay, now to go over domain 2.2. So domain 2.2 is explain common threat vectors and attack surfaces. So vectors and attack surfaces. This is pretty much the means to which a threat actor gets to us, gets into our network, gets into our enterprise. So in this first section, we're going to go over image, message, file, voice-based vectors, and also vulnerable software. Okay, so threat vectors, let's just describe that. A threat vector in cybersecurity refers to the means or pathway through which a cyber attack is carried out. So if I send a phishing attack, that's via email, right? That's the threat vector that gets the user to click on that link that downloads malware. If I'm calling someone and they give up their information, their username and password, that threat vector is VoIP or a phone. So let's go over these different threat vectors. And later on in this section, we're going to actually go dive into the terms phishing, smishing, and vishing. But for now, we're just talking the actual vectors themselves, okay? So email is a common vector for phishing attacks, malware distribution, and social engineering. So risk associated with email threat vectors is, again, getting malware downloaded, phishing, spear phishing, another technique called whaling, where it goes after like CEOs. And then also business email compromise. So to break down business email compromise just a little bit more, imagine we work for trepatech.com. So you go to the website, trepatech.com, that's our domain name. So if an attacker is trying to, do a phishing campaign against my organization, more than likely, what is the email address going to be? First dot last, or first name, or first initial last name at what? Your domain, trepatech.com. So it's easy for attackers to just look at a company's organization, look at their domain name, their front end website, and say, hey, look, trepatech.com. Now let me go on LinkedIn. Let me look for the different employees. Let me try sending an email to employee Dave Atkins, right? So I tried dave.atkins@trepatech.com, dave@trepatech.com, d.atkins@trepatech.com. I'm trying all these variations to try to get that business email compromised. It's a phishing attack, but it's easy because you know what the domain name is more than likely going to be. And also you can kind of just look it up as well, the email domain name. So not going to show you that right now, again, as a crash course, but that's one of the risks with this email as a threat vector. SMS can be used for what's called smishing attacks or SMS phishing. This is where you get a message saying Amazon's delivering a package, click here to verify, pay this toll road. You click on a website, you give up credit card information, or you try to sign into your Amazon account. So you give up your username and password. Attackers do that credential harvesting. Then they attack other websites that they assume you use the same password for. So the risk of SMS-based attacks or SMS threat vectors is smishing, fraud, and data theft. IM is the same exact thing, guys, as smishing, except it's just your social media presence, right? It's your instant messaging on Instagram, Facebook, whatever the case may be. The attack is something similar. It's trying to, get you to give up information, log in somewhere. It does a lot of impersonation, like small businesses. This is my small business Facebook Messenger. This is a screenshot from it, trepatech.com, right? Or Trepa Technologies. And I get these messages all the time where people fake that they're from like Meta support and they're like, log in here. This is Meta support. Your page violated this. If you don't log in, we're going to take it down. It's just impersonating, right? The support desk for Facebook. It's really cringe, right? It doesn't work. But I can see a small business, a mom and pop shop, they make their Facebook business page. They don't know anything about cybersecurity. And IM's a big vector for them, right? Because they may not know that Facebook Help Desk does not hit you up in Messenger. Image-based threats. So attackers use images to exploit vulnerabilities in image processing software or embed malicious code. This can include something called steganography, where we hide executable code within an image file. So the risk with these image-based threats is malware execution and exploitation of software vulnerabilities. File-based threats. So this is such an umbrella term because like malware, viruses, and all the different types of malware and viruses that you may have are file-based, right? Where they get installed on your C drive and there's some sort of file there that runs, right, that malware. For most types of malware, we'll get into that a little bit later. But malicious files can be disguised as legitimate documents or media files. So an age-old attack, right, is we use email as a threat vector. to send an attachment to a user that says download this attachment and open it up. And you think it's a PDF, but actually it's a executable disguised as a PDF, right? So that's a file-based threat. So with these file-based threats, what are our risks? Installing malware to include Trojans, ransomware, worms, or just exploitation of software vulnerabilities. It could just run a script and in the background it's running a daemon or a startup service that's exfiltrating data. So you may not even know you downloaded malware. Voice call threats. So this is called voice phishing or vishing. This is where an attacker uses the phone. They're using a phone to impersonate that they're someone high up in your organization, the help desk team, whatever it is, to actually, social engineer you to give up information. Removable device threats. So removable devices like USB drives, they can contain malware. I don't remember, this is probably 10 years ago now, but there was a famous attack where people were hackers, were going around and dropping USBs in parking lots. And employees would see the USB, maybe they labeled it the company's label, because you can do that. You can custom make USBs, your own labels. So the employee says, oh, this is for my organization. Someone dropped their flash drive. I'll bring it in, plug it in my computer and see who it belongs to. And now they're infected, right? So removable devices. You want to make sure that you're not just plugging anything into your workstations, whether that's a disk, USB, or even a micro SD card. So you have to, when you're using a removable device, get it pre-approved, make sure it's approved for your organization and your enterprise. Don't just go plugging random things in. Okay, now to go over vulnerable software, client-based software. So software installed on clients being computers, mobile devices, endpoints, can contain vulnerabilities that when exploited lead to unauthorized access or data compromise. So it's just saying that there may be software on your device already that can be exploited, right? Agentless. So agentless security solutions monitor and manage network devices without installing client software on each device. Vulnerabilities in these systems could lead to network-wide risk. So what we're saying here is that we have servers and services that run in our enterprise that connect and talk to all of our users. Think of like a SIEM appliance, a security information event management appliance, like Splunk. If that gets infected, well, what could possibly happen? If that centralized server that makes all these network connections gets infected, imagine if a worm gets installed on there that's self-propagating, that its whole purpose is to pivot throughout the network. You're going to have a lot of breaches, and you're going to have a big network intrusion and a big breach on your hands. So you want to make sure that our software or services that run agentless scans, or its goal is to connect to all of our users, you want to make sure there's no vulnerable software there. Okay, so that was domain 2.2.1. Remember, this is a crash course, so we are going just a little bit fast. Now, let's go to domain 2.2.2 and continue on for our domain 2 lesson. Okay, so continuing on with domain 2.2, now we're going to go over unsecured networks, open ports, default credentials, and supply chain. So now we're going to go over like the different vectors when it comes to the actual network, right? So wireless, wired, Bluetooth. We're going to go over some hardening things, some basic things we need to do to reduce our attack surface, and then other things that we a lot of times don't think about, like our supply chain. So let's dive right into it. Okay, so the first unsecured network we're going to talk about is Wi-Fi or wireless. Now, what this is trying to say to you is that, hey, when we just set up a Wi-Fi network, like the rudimentary technologies of Wi-Fi that came out in the 90s, we set that up. It's just a Wi-Fi signal being broadcast from access point with an SSID, and you join it. There is no protection there. When you send that 802.11 data frame, there's no encryption there. The standard nothing Wi-Fi that was first invented was not secure. It was a Wi-Fi network that used radio waves that anybody that was listening on those channels or that frequency could connect to. So there was inherently no security with Wi-Fi and wireless. Now, obviously, this was a long time ago. Now it's the year 2025. So we have, I say we because, I was there, even though I was like 4 years old. But there's security now. There's security on our Wi-Fi. So there's two different types of security we're going to talk about. One, actual encryption that does like the data in transit encryption for our 802.11 frames, and then also the authentication. So we don't just do open authentication anymore. We have more advanced technologies like using the extensible authentication protocol and the Wi-Fi protected access protocol. So a Wi-Fi network is a wireless network that uses radio waves to provide network connectivity. And by its defaults, with no protection put on there at all, the risks are man-in-the-middle attacks, network sniffing, unauthorized access, and Wi-Fi spoofing, which Wi-Fi spoofing It's gonna kind of always be a risk, even with like encryption. We'll get into that when we get into like evil twins and rogue access points. But when it comes to Wi-Fi encryption, there's something called Wi-Fi protected access. Now, originally there was a standard called WEP, which is deprecated, okay? That's the wireless encryption protection, I think is what it stood for. But now we moved on to WPA, and there's 3 versions of WPA. There's the first version, which is Wi-Fi protected access, which is also deprecated. And then we have Wi-Fi protected access version 2 and version 3. Now, both provide us advanced encryption. So both are going to do AES encryption. But one of the differences in just the pure encryption is WPA2, I'll put a little line here, uses something called CCMP, while wireless or protected access 3, WPA3, uses something called GCMP, which, without getting into the actual like details of it, GCMP, Galileo's counter mode protocol, is stronger and better than CCMP. So WPA3, we have enhanced just straight up encryption. With WPA3 as well, we do something called simultaneous authentication of equals, which is an advanced standard provided by WPA3, which protects us against brute force attacks, and also gives us something called PFS, perfect forward secrecy. Now, again, when we have these Wi-Fi protected access standards and protocols, there's 2 ways we employ it. We can do WPA PSK, which means when we actually authenticate, we're just sending a password. This is what you do at your house, right? You just have a password. Or we have enterprise mode. SAE was kind of specifically meant to protect pre-shared keys, right? So we didn't have that brute force vulnerability that you had in the previous WPA2 standards. But beyond that, guys, just to simply explain this, enterprise mode versus PSK is just a single password that you send to the access point, or really more accurately to that wireless network, because an access point can broadcast multiple SSIDs that correlate to multiple wireless networks. More on that later. With enterprise mode, you have credentials, so you're going to have a username and password. And with enterprise mode, your access point's actually going to talk to some sort of authentication server using something like a AAA protocol like Radius. Okay? More on all this stuff later. Like, we don't want to dive too deep into this now, but just know that Wi-Fi inherently is insecure, but we have things that now make it secure, like WPA 2 and 3, which use AES encryption, with WPA 3 using GCMP, that's a G, which is stronger. The bit key lengths for AES that is used in WPA 3 is going to be 128, 192, and 256. And then it also has enhanced security using simultaneous authentication of equals, which gives us brute force protection and perfect forward secrecy. Okay, another attack surface, I guess you can call it, or another unsecured network is wired networks. So they're not as inherently insecure as Wi-Fi is, because obviously with a wired network, you have to plug into a switch. And if you don't have access to that switch, it's in a comms closet, and all the wall jacks are just like shut down, then really what are you gonna do, right? You can plug in your Kali Linux Raspberry Pi into a wall jack in the reception area, but if that switch port that connects to that wall jack is literally turned off, you got nothing, right? But there is ways that we still want to protect our network access control when it comes to wired networks. So wired networks are still susceptible to unauthorized physical access, port stealing, or tapping into unsecured ports. So imagine that switch port's completely open, and somehow, some way, we get access to that port to plug in our malicious device. Well, to prevent the malicious device from actually getting access to our network, we have a couple different ways we protect. One was something basic called port security, which is going to control how many MAC addresses can live on that port. If you understand, we haven't dived into it, but switch ports, so a Cisco switch, a switch, right? They forward frames, they forward packets. It's called frames when it's layer 2. They forward frames based on MAC address. When a device connects to a switch, it builds a frame, and in that frame header is a source MAC address and a destination MAC address. The switch looks at that source MAC address and inputs it into something called the MAC address table. Think of it as just a spreadsheet that says, hey, on this port number, gig02, lives this MAC address, and that MAC address identifies your workstation. So we build this MAC address table with ingress source MAC addresses, and then that that frame that came in has a destination, needs to go somewhere as well. We look at that destination MAC, reference the MAC address table, and then send it off. So understanding that basic layer 2 switching fundamentals, what is a way we could prevent a malicious device from being plugged into the switch? So imagine we're plugged into the switch here. I'll bring my pen back out. Oops. Go back. So again, imagine we're plugged into this switch. So I'll draw a switch. Okay, this is our legitimate device. And we're plugged in on gig 0/0. Cool. We're plugged in there, gig 0/0. And we say, hey, we're going to open this port. It's going to be open. And then someone malicious comes in. I'm going to get red for this. Someone malicious comes in and unplugs you and instead goes to their evil box. Goes to their evil box. There's a sad face, but I don't know how to draw an angry face. And now they get access because there's no port security. We're just letting any MAC address connect there. Well, one thing we can do that I have an example of down here is we can tell that switch port specifically, like Ethernet 01, in our case would be gig 00, and say, hey, for this port security, we're only going to allow a maximum of one MAC address. So that means when this computer is plugged in and we have this command here sticky, it's saying, hey, we're going to recognize that this source MAC address, whatever this user is the only MAC address allowed. So port security is just MAC address filtering, right? And if that evil person tried to plug in their Kali Linux or Raspberry Pi, since we only allow one MAC address, guess what? It's going to say, whoa, 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 that's a second MAC address trying to enter this port. No way. I'm going to go into an error disabled state. So that's one way we can protect our wired networks. Another way is going to be something a little bit more advanced. It's going to be something called network access control. So network access control is a combination of things. It's using AAA protocols with the 802.1x protocol that authenticates you onto the network, okay? So with network access control, we use a AAA server, 802.1x, configured on the switch using things like Radius and the 802.1x protocol itself, and saying, hey, this computer, we built in our AAA server. So we put that computer's MAC address in our AAA server prior. Maybe there's a license that we put on the computer that we put, not a license, but a certificate on that computer that we put on this AAA server. And when it tries to connect, we're going to forward that computer's information to the AAA server, and it's going to authenticate for us and say, yes, this computer is allowed network access. So if you're not like pre-approved, is what we'd call it, in your network access control scheme, however you build it out, and you try to plug in, you're not going to get any network access. The switch isn't going to allow you to get a VLAN. It's not going to allow you to do DHCP, get IP addressing information. You're not going to get allowed access. So that's another way we can protect our wired networks. And then the basic way, right, is physical security. You know, if someone has to enter a comms closet to get access to our switch, make sure that thing is locked, maybe a badge reader, physical security as well. Another unsecured network the Security Plus wants us to talk about is Bluetooth. So Bluetooth connections can also be exploited. They can be exploited for eavesdropping, unauthorized access, or bluejacking. That's where we send unsolicited messages, kind of like a Bluetooth denial of service, you kind of look at it. So risk when we have open Bluetooth environment. So imagine we have like Internet of Thing device that has Bluetooth on our enterprise, and now attackers are, using that as a vector to get into our network. So we have things like blue snarfing, blue bugging, and blue-borne vulnerabilities. And to mitigate against Bluetooth attacks, we just want to use the latest versions and disable Bluetooth when not in use. All right, now let's go over how we can harden and reduce our attack surface. So this isn't really necessarily talking about a threat vector. Like an open port, it can be used to be exploited. But here we're talking more about reducing our attack surface, making sure that our endpoints, our servers, our workstations are not easy targets. So open service ports. When there's open ports on a network, that can act as an entry point for attackers. So we look at our internal web server here. We run an Nmap scan, which lets us know the open ports and the IP address and protocols on devices in our network. We notice port 80 is open. So what does that mean? We're allowing port 80, which means hypertext transfer protocol, which is inherently insecure, right? So it kind of opens the door to be exploited. Maybe we run an Nmap scan and we notice that telnet is enabled on a switch. So if telnet's enabled on a switch and someone telnets to that switch and there's a malicious actor sniffing the packets, somewhere, right, on path, they're going to learn our credentials. They're going to be able to do a packet capture. So really the main point here is if there's open service ports, close them. Close any unnecessary ports, do your port scans, and make sure that you're hardening your devices to not allow any open ports that are not in use, right, or that are not needed. Okay, default credentials. So a lot of times the systems that you'll have in your enterprise come with default local administrators, local users. We look at IoT devices, which, IoT devices, those IoT devices, they don't have, security baked into them because the vendors are just trying to get that IoT device to market. They're not really worried about the security of that. So when you have those default credentials that maybe someone could look up, they say, oh, you have a Nest AC thermostat, this model, let me look up these default credentials and see if I can get into it and maybe make that my pivot point or my persistence point to get back into your network. So you want to make sure that any device you're putting on your network, harden it by getting rid of the default credentials, disabling them, or changing them. Another thing that we have to worry about as a threat vector is our supply chain. So in this section, we talk about supply chain in the view of a company hiring an MSP or an MSSP, or what's the next slide? Just vendors in general. So let's talk about supply chain. The supply chain is just where a hardware, piece of software starts to when it's on your network, right? If it's manufactured in Taiwan, China, India, Vietnam, all the way to sitting at a user's desk in America. Now, I'm American, right? So I always view that in that perspective. But that's what the supply chain is. And every step along that chain, is there a point where we could be exploited, where the thing that we're going to put on our network, software, hardware, is it being a vulnerability put on it any step of that supply chain? Now, that's the overall definition of supply chain when it comes to cybersecurity. And pretty much the answer to that is you got to vet. You got to vet where you're getting stuff from and understand where it's coming from. Now, in this slide, we're talking about MSPs. So MSPs, managed service providers, are IT-based. They're IT companies that companies hire to run their IT. So imagine small to mid-sized businesses. They may not have the capability, the infrastructure, the resources to host their own IT teams and operations to run all their IT services and what they need to run the company. So they hire outside. They hire an MSP. So when you hire that MSP, they get admin access to everything. They set up your Office 365. They set up Microsoft Intune. They set up your network infrastructure, and they set all those permissions. So at some MSPs, they're going to be a single person or a team of people that have admin and root access to all these different businesses. Now, what happens if that MSP technician or admin goes rogue? Or what happens if that MSP gets breached? So obviously, that's something we have to think about when hiring these vendors to come in and manage our IT services. So that's part of our supply chain, something we have to think about. Now, mitigation here, it says vet MSPs thoroughly, establish strong contract security requirements, and monitor MSP activities. This is more of a Sec Plus-ism. If your organization's already hiring that MSP for full-time IT operations, do you have anyone that can monitor it? Sometimes we have a scenario, though, where we hire an MSP just for specific things, and we still have a local IT admin, and they got to work together. So hopefully there's some sort of separation of duties there where our IT admin still has control, but the MSP comes in and does work for us, like break fix contracts, things like that. Okay, then vendors. So vendors who supply software or services can introduce vulnerabilities if their products are compromised. So again, just have a vetting process. One thing that happens with local companies, when I say local, maybe not global enterprises, is they buy from local what's called VARs, variable authorized resellers or authorized resellers, right? And maybe those resellers take end of life, end of support equipment and resell it to you. And then they put their own little warranty on it. Well, where are they getting that? When they got that device, how did they clean it? Did they put a bug in there? So there's a lot of things we have to vet when we look at our supply chain. If we're going to the local market to buy equipment, not straight from the source vendor, like going straight to Dell, right? We go through a middleman, which is typical. That's typical to go through VARs to supply us with hardware. Are we sure that they can be trusted? So we just got to vet our supply chains, okay? Third-party breaches, conduct vendor risk assessments, and ensure the vendors meet security standards. Maybe they make sure they meet your security standards. Your security standards are set by the organization based off risk appetite, based off compliance, based off so many different things. And you want to make sure the vendors you work with meet those security standards. Okay, now let's move on to the last section of Domain 2. All right, so the last section in Domain 2 is going to going over threat vectors and attack surfaces. We're going to talk about human vectors and social engineering. So now we're actually going to get into like the actual attacks, right? We went over the threat vectors, now the actual attack. So phishing. This is a technique where attackers deceive victims into revealing sensitive information through email. So guys, how do we protect against phishing attacks? The number one answer for protecting against social engineering is always going to be education. That's going to be the answer all the time on like these certification exams. It's always going to be, well, I can't say that for certainty, but that's what the point is, right? Cybersecurity isn't always you being a hacker. It's a lot of policy. It's a lot of the times just looking at SOPs and establishing programs to protect your organization. So if all these social engineering attacks, a lot of times the best protection is going to be education. Educating the users, having some sort of cyber awareness training program that teaches users how to recognize social engineering attacks. Beyond that, some of the more technical things we can do is use email filters, set up SPF records, DMARC records, DKIM records, and our DNS servers that protect our domain, specifically our emails. Verifying sources before responding to requests, kind of just looking, right, hovering over and seeing where is this actually from? Is this a legit domain? And then something else, guys, like let's say you can't stop the phishing attack. Someone falls victim and they give up their credentials. They log into the site, the fake phony site that was sent in that phishing attempt. To protect credentials, there's always going to be multi-factor authentication, right? You always want to have some sort of multi-factor authentication in case a web credential does get breached or does get stolen. Okay, phishing, that's voice phishing. So it's the same thing as phishing, just conducted over the phone. The threat vector isn't email now, it's over the phone. The goal, financial fraud, get unauthorized access to personal accounts. And again, the mitigation is generally going to be around education, verifying caller identity, being cautious with unsolicited phone calls. But that's on us to tell our users to do that, right? Be cautious. And then also just don't give up information over the phone. It's kind of just basic stuff, right? And then smishing. This is SMS phishing, a form of phishing conducted through SMS or text messages. The risk is just scams, getting someone to log in, financial fraud, credential harvesting. Don't click on things that don't make sense. If you know the thing with like the toll road one, it's so good because like I've owed tolls before. I just had to renew my registration in North Carolina, and they're like, you can't because you need to pay your tolls first. I called the DMV. I'm like, okay, paid it real quick, went on the site. But you get a text message of that. It seems legit, right? It's like, yeah, I probably do have unpaid tolls. So you just want to be very cautious about clicking on unsolicited text messages when there's links in there. Verifying the source. You can look up the phone number online. Sometimes it'll come up as a spam number. You can call your phone carrier provider and say, I want protection against spam bots. There's applications that protect against spam bots now on the app store. So education and again, some of those technical controls. Okay, now let's go over how someone accomplishes social engineering. So all that's the type of attacks, their vectors. But now how do they fool you? How do they trick you? So impersonation. This is where attackers pretend to be someone else, often an authority figure or a trusted individual. So they build trust by maybe pretending they know someone in your family, they know your grandson, right? They're targeting our elderly community. Or they're saying, I'm the CEO, I'm the CFO, right? And that would scare someone, especially if you have a new job, right? So if impersonation is successful and the social engineering attack is successful, how do we mitigate that? Multi-factor, right? If someone's credentials do get harvested because they gave them up or whatever the case may be, multi-factor authentication will save you even if an attacker has a legit username and password. And then, of course, awareness training, right? Always want to train your users to look out for these things. Pretexting. I call this advanced gaslighting, right? It's social engineering gaslighting. It's pretty much creating a fabricated scenario to engage a victim in a manner that increases the chances of divulging confidential information. So a pretext, hey, you send a text message, we're going to be doing this training. I'm an attacker sending a text message. We're going to be doing training on Friday. Make sure you be there at 12 a.m., whatever the case may be. This is from the IT team. So then the training happens, you send them a link, like a Zoom link to the virtual training, and then they try to sign into the Zoom link. They're like, wow, why is it not just working? I have to sign in. It's a pretext, right? Building a fabricated scenario, trying to trick that user into thinking they do need to do something. Advanced gaslighting, right? All right, another attack we're going to talk about is a watering hole attack. So this is compromising a frequently visited website by a target group to infect their systems with malware. So why is this in social engineering? This seems pretty technical. Well, because essentially when we're targeting a group, targeting a company, let's say we're conducting reconnaissance and we notice that they go to a share portal that's open, that's actually open to the public internet. So we notice that users from 9 to 10 are always logging into this one website in this company. So now it kind of makes it easy for us to say, hey, instead of trying all these different avenues and threat vectors, let's just focus on that one website. If we can infiltrate that website, we get access to try to, exploit all these users, So that's a watering hole attack. It's based off, the gazelles at the watering hole. So where the lions hunt, they know the gazelles are going to be there. We know that users are going to this site, so we'll just attack that site. So mitigation is just regularly updating and patching browsers and software using web filters and educating users on secure browsing habits. Okay, last attack we're going to talk about is typo squatting. So typo squatting is just looking at a very popular domain and then buying a domain name that's similar to it. So you're betting on a user putting in the bad domain name just on accident, like a typo error, right? When they're putting in the URL, and then they go to your bad domain, which you just copied the website. You just make the website look as real as possible. They sign in, and then boom, you got their credentials. Or it could be for them to download malware, right? You go to this bad site, you click a link, immediately that downloads something. So that is typo squatting. Just pretty much this picture here, if you memorize this picture, you'll know what typo squatting is for the exam. We're trying to trick people to go to ourexample.com by putting in a little extra E there, hoping someone will make that spelling mistake. Okay, so that was domain 2. Now let's move on to domain 2.3. Okay, now we're going to go over domain 2.3. This is going to be explain various types of vulnerabilities. And in this PowerPoint slides, we're going to go over application, operating system, and web-based attacks. So here's all the objectives we're going to cover in domain 2.3. Let's go ahead and get started. So when we go over this domain, I like to just preface this. This is a crash course again, just to remind you, but in the Security Plus exam, we're not going to teach you how to build these attacks, build these vulnerabilities and these exploits. We don't need you to have a deep understanding of all these attacks just to pass the CompTIA Security Plus exam. I'm not saying that you shouldn't. I'm just saying for the exam, we have our priorities. So when we go through all these different types of attacks, if you don't understand, you can't explain it, you can't write a white paper on it, don't feel like this fraud syndrome or whatever the case may be. A lot of the times in this blue teaming, we have to just understand the tools and techniques to prevent this attack. We don't necessarily have to be the guy or the girl, the person that's inventing these new malware vulnerabilities and reverse engineering them. Because reverse malware engineering, that's very hard and that pays a lot of money, but that's not our goal here. So just keep that in mind as we go throughout domain 2.3. We don't need to have a deep understanding of all these different attacks. Now with that being said, let's get into these different vulnerabilities. So memory injection vulnerabilities. So memory injection involves inserting malicious code into a program's memory space. As we know, when we run applications on our systems, we get assigned a memory block to run that application from our RAM or our memory pool. So memory injection is going to insert malicious code into that program's memory space. How it occurs. Often executed through vulnerabilities that allow an attacker to inject code into running processes. This is often due to insufficient input validation. Input validation, when it comes to our applications, we're going to learn about a lot. It's one of the ways we protect against pretty much all injection-based attacks, whether it's web-based, memory injections. Input validation protects us from those injection-based attacks by essentially not letting anyone input anything malicious into our applications. So the impact, this can lead to unauthorized data access, system compromise, and execution of malicious code. But how do we prevent memory injection? We do this by regularly updating software to patch any vulnerabilities that may allow memory injection to happen. We can use something called data execution prevention. And we also always need to have input validation on our applications, whether they're web-based or on a system. Buffer overflow. This is another memory type attack. This occurs when more data is written to a buffer than it can hold, leading to data overriding adjacent memory. So this is due to programming flaws. So the consequences of this is erratic program behavior, the system can crash, and there's also a gateway for attackers. So it says here the mitigation, use safer programming languages, but you don't necessarily need to. You can still use C, C++. It's still used. It hasn't gone anywhere. Maybe not as popular for people to learn, but it's not going anywhere. Really what we need to do in our programming and our source code for our applications is do bound checking and implement what's called stack canaries. Now again, we're not going to dive deep into that. just know how do we prevent buffer overflow. It's really just with good programming practices and good coding security practices. Okay, another vulnerability we're going to talk about, something called a race condition. A race condition, or something, or a time of check, time of use. Pretty much they're synonymous. So this is when this condition occurs is when the system's behavior is dependent on the sequence or timing of other uncontrollable events. So I always like to look at it like a good example of this, right? You ever logged into your computer, and when you log into like a domain joined computer, we're talking like Microsoft Active Directory, and all of a sudden you can't get to certain shared drives, you can't get access to the things you normally do. So you log off or you restart, you log back in, and all of a sudden it's fine. Well, that's because somewhere in that, the permissions being applied to your account, there's an error. Most likely due to the sequencing. That is like time of check, time of use errors. So TOC/TOU involves a time gap between the time of check and time of use of a data value, leading to a window where unauthorized changes can be made. So a good example, a file's permissions might be checked at one point, but by the time it is used, an attacker may have exploited this window to gain unauthorized access. This was actually first proven by a cybersecurity researcher that manipulated the functionality of transferring Starbucks credit cards on their website, where to break it down simple, because remember Crash Course, he proved a race condition would happen by he just kept sending these Starbucks gift cards to his own account over and over and over again. We'd have $5 here, $5 here. He kept sending, and eventually he just kept increasing the amount of money he had, even though he only started with $10. If you want to look it up, I'll put it in the description of this video. It's pretty cool. It's pretty much the first time a race condition was proven, where before it was just taught in like computer science as something that could happen. Sorry, how do we prevent this? Using locks to synchronize data access, just having synchronized data flows. Okay, malicious updates. So what we're talking about here is like in Linux, when we have like repositories that update our software, or we get an update from a vendor and there was malware introduced. So sometimes we can apply an update and all of a sudden malware was embedded into that. So this refers to unauthorized malicious code being introduced into a system through an update. So how do we protect against this? Obviously, the defense strategy is get your patches and your updates from trusted sources, verify the updates, make sure they weren't changed in transit. So using things like digital signatures and hashing to verify the authenticity. Okay, another injection attack, something called SQL injection. So SQL is what runs our databases. This is the language that has all the tables and columns and rows that stores all the information for like your web application or for whatever data is being used. It's your database, structured query language. So when we send SQL commands, right, from our backend process to our database, that's something that happens in our web server and our web application or our applications in general. It's not supposed to be exposed to the front end. So what I mean by that is when someone conducts a SQL injection, they're given a user input on the front end of a website. So imagine username and password. And instead of putting in username and password, you try to input SQL code. And the SQL code you put in maybe attempts to drop the database. So when you put in that SQL code, you hit login, instead of your website processing your username, it's processing that username, that SQL code. It sends that back to the database, because remember, it's trying to get the username and verify the username is correct. That's stored in the database because you're trying to log in. And instead it's SQL code that drops the database. So that's a SQL injection. So you may say, why would we ever allow this? Why would we allow user input fields then? Well, you kind of have to. You have to have someone log in with username, password, credentials. But how do we protect against this type of attack? We prevent this by input validation, saying, hey, your username cannot have these characters, cannot have this special characters that are SQL code. So input validation is one way to prevent it. Also, using something called parameterized queries or stored procedures, that's a fancy way to say having a drop-down menu. So instead of letting a user choose their favorite color by typing it in, let's say we're just answering, I don't know, security questions and ask what's your favorite color. And instead of you being able to type in the favorite color, it gives you a drop-down of all the colors available. We call that parameterized queries. So instead of giving you the option to input your own text, we say, we're just going to give you a drop-down and you're going to choose from this list of options. That's parameterized queries or stored procedures. Main thing, to prevent against injection attacks, whether it's SQL injection, LDAP injection, any sort of injection attack on your web application, input validation is how you protect it. Okay, another vulnerability we're going to talk about is cross-site scripting. So cross-site scripting is a vulnerability that allows attackers to inject malicious scripts into web pages that's then viewed by others. This happens a lot in like forums, right? Well, back in the day, it happened a lot. You had an open forum, people would put, this malicious script and would try to get someone to click on it. So we have 3 different types here. We have reflected, stored, and DOM-based cross-site scripting. We're not going to dive deep into those different types. What we do need to know is how do we prevent cross-site scripting. We prevent it by implementing something called content security policy, something that protects our websites, like the front end, and then also use input validation. Another way to protect against cross-site scripting, which is another way, it's not called an injection attack, but it is. It's injecting something malicious into a website. Input validation. Do not let people type in that malicious code into the website. Okay, now let's move on to our next section in Domain 2.3. All right, so continuing on with Domain 2.3, now we're going to go over hardware, virtualization, cloud-specific, and supply chain vulnerabilities. So hardware vulnerabilities, understanding what this is. So hardware vulnerabilities arise from physical devices like computers, routers, servers, switches. It's the actual hardware and how they get exposed. So how hardware can be exposed or become vulnerable. Hardware can have something called firmware vulnerabilities. Well, this is weaknesses in the software programmed into the hardware device, like the firmware that sits on your motherboard. We can have end-of-life hardware. So this is when a piece of device the vendor no longer supports, or really no longer sells. So end-of-life, end-of-support means it's not receiving updates or support anymore. So now it's vulnerable to attacks. So if there's ever an exploit or a vulnerability on that server, that router, that switch, whatever legacy device hardware we have, no vendor is going to put a patch to it, right? So older systems may not be compatible with current security standards or software updates either when they're legacy devices. They may not meet some sort of compliance that you may have to adhere to in your industry. So how do we protect hardware vulnerabilities? Constantly updating, constantly patching as best we can, having just a patch system in place, replacing end-of-life hardware if it's feasible, and try not to use legacy devices. Now, obviously in some environments like OT environments where you're in factories, sometimes it's just not possible, right? You have to use legacy devices, but trying to limit legacy devices on your enterprise. Okay, cloud-specific vulnerabilities. So in the cloud environment, we have something called the responsibility matrix. So what does that mean for us? When we deploy services in the cloud, that's a cloud service provider. That's what CSP stands for. Well, depending on what service model we use, whether that's infrastructure as a service, software as a service, or platform as a service, we're going to have our responsibilities on what we need to protect. So no, we don't have to worry about, protecting the physical security of a cloud data center because that's not on us. If we're configuring infrastructure as a service and deploying a VM in the cloud, guess what we're still responsible for? The network security, the identity access management, patching that operating system, scanning that VM, because it's an operating system. It's like a computer we're using. It's just hosted in a cloud data center, and we're getting console access or access to that via the cloud, right? But there's things that we manage in the cloud we have to protect. If we have APIs in the cloud, we got to make sure they're not insecure. We have proper authentication to those APIs. Making sure we can still get data breach in the cloud as well. If we leave open ports and services on a virtual machine, just because it's in the cloud doesn't mean it's not exposed. It's even more exposed. Because if it's a public cloud and you're deploying that VM with a public IP and open ports and services, it will get exploited. So we have to make sure we're still doing the hardening that we would do on-prem. How does that transfer over to the cloud? Pretty much you're doing the same thing. No default credentials, no open ports and services. So making sure that's hardened. And then identity access management. Because in the cloud, we get access to our cloud service provider via a console or a portal. Well, how are we logging in? If we're logging in via username and password, well, guess what? There's one of your vulnerabilities. If someone steals username and password, they're getting access to your whole cloud console, and that's not a good day. And then the basic things like encryption, access controls that we would do on-prem, we still do in the cloud as well. Okay, and then talking about supply chain vulnerabilities again. Sometimes Sec Plus does repeat itself in the exam objectives. That's okay though. So supply chain vulnerabilities. So service provider. So risks that arise from third-party service providers include cloud hosting services, managed IT services like MSP. We have hardware provider risk. So vulnerabilities stemming from hardware suppliers. Did someone put a backdoor on our motherboards, right, and our servers, and our name's AWS, and we got our stuff from China, 2016, 15. And is there already installed malware or compromised components that we're getting? Then we have software provider risk. The dangers of using like a SaaS application. What are they actually doing with our data? Are they actually adhering to strict cybersecurity practices? If we're trying to bring in a third-party application into our systems, does that provider have compliance already for whatever industry we work in? Okay, now moving on to our next section in Domain 2.3. Okay, finishing up Domain 2.3, now we're going to go over cryptographic, misconfiguration, and mobile device vulnerabilities. Last section in Domain 2.3. So cryptographic vulnerabilities. This is any flaw in your encryption algorithm or their implementation, meaning private keys getting exposed. Maybe you have weak encryption algorithms, you're still using RC4 or like MD5 hashing. You're not properly managing your keys. So again, private keys getting exposed, that's a huge one. And the impact, it can lead to data exposure or system compromise. Pretty much the fix for any cryptographic vulnerabilities you may have is use the most up-to-date encryption as best you can. Now, obviously, if you have some legacy devices that can't, it is what it is. It's better than nothing, better than plain text, but making sure that you're using the most up-to-date encryption. TLS 1.2 and above, AES for symmetric, RSA or ECDSA, ECC for our asymmetric encryption, and making sure you're using the strongest bit key lengths as well. And then not exposing keys, not exposing private keys. Misconfiguration vulnerabilities, what this is really saying, guys, is just, we set up a web server and we did bad error handling. We left ports open. We had unnecessary services enabled. Our default credentials weren't changed. So because we didn't do the proper hardening of when deploying a device, maybe it gets exposed, and then all of a sudden we do our hardening after the fact, okay? When I say bad error handling too, if you look right here, we try to go to a website, it was a bad URL handle, and instead of just giving us an error that just says can't connect, it gives us a 400 error, which is fine, but then it tells us we're running Apache Tomcat 5.5. So if an attacker is trying to get information about your server, and this is how you do error handling, pretty much exposing your operating system type, what version, what update. Now I can go look that up and be like, is there a vulnerability or an exploit on this OS version or type? So you want to make sure, you're doing error handling correctly. Making sure you're doing good web architecture as well. The example on here is an unsecured database accessible over the internet. You should not be able to access the database of the web application you're reaching. There should be separation. There should be APIs on your backend server that does the interaction between your SQL database, not direct access to the front end. So making sure you just have good architecture set up as well. Okay, mobile device vulnerabilities. So this is when you have the mobile device fleet in your enterprise, doing something with enterprise data. Do we want to make sure we're not leaving that exposed? So some weaknesses to mobile platforms. Sideloading. This is installing apps from unofficial sources, bypassing security checks. Because typically when you have like mobile devices in the enterprise, you lock them down a little bit, you harden them. You use mobile device management to say, hey, you can only download from this app store that we approve. You can only access and download things over cellular or the business Wi-Fi. We're enforcing you to use full disk encryption. We have remote wipe capabilities. We containerize the enterprise apps away from your personal apps. So we have MDM that does all this, but some common issues they want you to know about is like sideloading, installing apps from unofficial sources, or jailbreaking the phone. So removing the default restrictions, which can expose you to security vulnerabilities. So the impact, it can lead to data leakage, unauthorized access, and malware infection. Especially when you're sideloading apps, right? Because typically the App Store, Google Play Store has some sort of verification that your app's not malicious, right, in nature. Obviously, it can still be a keylogger and other things in the background, but okay, zero-day vulnerabilities. So a zero-day vulnerability is something that has no patch because it's brand new. This is an unknown vulnerability. Something that CISA, there's no CVE for it. CISA, the organization that makes CVEs, right? There's nothing for it. It's a brand new attack, a brand new malware that we don't know about, so we cannot do nothing to fix it. The only thing we can do is try some compensating controls, isolate the device that's infected with this zero-day vulnerability, but there's going to be a breach because we can't fix it. When there's a zero-day vulnerability, essentially we got to go to the vendor and ask for a patch, right? And, publish our zero-day vulnerability to the cybersecurity industry, right? So example, a zero-day exploit used in widespread ransomware campaigns before vendors release a patch, okay? Just means there's no fix for it. All right, that was domain 2.3. Now let's move on to domain 2.4 in our crash course. Okay, so continuing on with our crash course going over domain 2, now we're going to go over domain 2.4. Given a scenario, analyze indicators of malicious activity. So again, we're going to go over a bunch of different malware. And a lot of times the prevention is always going to be, malware gets installed on an endpoint. How do we protect against that? Install some sort of antivirus malware, some sort of endpoint detection. Now, obviously, that's after the fact, right? There's prevention, like endpoint detection, anti-malware has prevention before the malware gets installed. But how did it even get there in the first place? Someone fell victim to a phishing attack. So obviously, before even our anti-malware has something to play in protecting us, we want to make sure users aren't downloading it. But again, I just want to reiterate, in this crash course, in the Security Plus, we don't need to understand how to build ransomware. We just got to understand how to protect it and mitigation steps. So keep that in mind as we go through these different indicators of malicious activity in this section. Okay, so let's go over it. We're going to go over malware attacks, physical attacks, network attacks. Then we're going to go over application attacks and general indicators of an attack. So understanding malware threats. So malware, malicious software, is just designed to damage, disrupt, or gain authorized access to computer systems. And there's multiple different types of malware. So first we're going to talk about is ransomware. This is malware that encrypts user data and demands payment for it. So it pretty much it encrypts your C drive or your hard drive and says, we're not going to give you access to any of your files, so you pay us. Moral of the story, you pay them, they keep asking for more. So how do we protect against this? Obviously, it's always going to be anti-malware, antivirus, endpoint detection and response, keeping systems updated. But specifically in like ransomware, if you have a good restore point, so let's say you back up your system on a Sunday, ransomware happens on a Tuesday. If you can back up that system back to Sunday, that ransomware won't be installed. So that's another clean way to, get your system back online from that. Trojans. So this is malware disguised as legitimate software. Typically, their goals are to create backdoors, steal data, or harm the systems. So prevention, mitigation, antivirus programs, anti-malware, and get software from trusted sources. A worm. So this is malware that's self-replicating or self-propagating. So it tries to pivot. It tries to go to other systems, other computers, and it can do that without user interaction. It doesn't need you to do something so that it can, pivot to another workstation. So how do we protect against this? Keep systems up to date, network segmentation, firewalls, right? Doing analysis on the wire. Spyware. So this is malware that secretly gathers information without the user's knowledge. So this is like spyware can be keyloggers, turning on cameras, harvesting data without you knowing. So how to protect against spyware? Again, it's going to be some endpoint protections like anti-spyware software, which is kind of wrapped up into our anti-malware, anti-software EDR solutions. EDR equals endpoint detection and response. And then making sure software is always up to date, regularly patch, right? And don't grant, so sometimes like it'll ask for permissions on the system too. And that'll pop up on the screen, say this software needs permission to access whatever. Hit deny if you don't know what it is. If you don't know what something is asking for permissions or what it is, then don't allow it. Okay, bloatware. So this isn't something that is necessarily malicious in nature. It's just unnecessary software that may come pre-installed or may come with the software application you're trying to install. And it's just not needed. It just takes up space. So there's really like the prevention and mitigation is just uninstall unnecessary applications. Use custom install options instead of the default one that'll install all this bloatware, right? Okay, viruses. So this is malware that attaches itself to clean files and spread to other files. That's what a virus, the definition is. So it's corrupting files, consuming resources, and spreads through networks. Again, how do we protect against viruses, guys? This is after the fact it's installed, okay? Antivirus. Now, again, I keep saying that because I don't want you to get confused with, I thought you said user education prevents malware from being installed. Yes, right? If that's how it got installed, like through an email, your user had to click that link. So that's obviously how we prevent it. But this is like, nope, it's there. Whatever happened, happened. The virus got there. Now, how do we get rid of it? Or how do we stop it from being installed? If something like that does happen, we download a link. Can the computer stop that human error? Antivirus software. Okay, keyloggers. So part of spyware, this is malware that records keystrokes and usually sends it back to some sort of command and control or some sort of malicious user. So the goal is to steal sensitive information. How do you prevent? Use anti-keylogging software, which again is usually wrapped up into your all-in-one anti-malware, anti-software solution. It says use virtual keyboards. Yeah, I don't think so. That's crazy. I mean, that's a way, but man. Okay, a logic bomb. So this is malware that's triggered by a specific event or time. So think of a logic bomb is, we have an APT that wants to do data exfiltration. So obviously we don't want to do data exfiltration during peak hours because someone may notice. They may notice like, whoa, why is my system running slow when it never does? So we try to do it maybe on non-peak hours. So we install, data exfiltration script on the accounting systems or the computers in our accounting department. And we put a logic bomb on there that says run this script at 2 a.m. and turn this script off at 4 a.m. And during those 2 hours, we're doing as much data exfiltration as possible, right? So they can lie dormant until something is triggered, a specific event triggers it. So prevention, regularly audit, monitor code, implement robust authentication and access controls. And again, a lot of scripts sometimes need permissions to run, like you think of Linux, needs sudo. So making sure we're doing, again, that audits, right? Making sure our permissions are scoped appropriately. Okay, a rootkit. So this is malware that grants administrative level control over a computer system, and this is hard to discover. It can hide its existence in other malware. It's difficult to detect and remove because it's on the root of the system, right? So prevention and mitigation, use reputable security software, maintain system and firmware updates, and also monitor system behavior. When it says monitor system behavior, again, this is going to be rolled up into some sort of software that does this for you, like endpoint detection response, EDR, or something called XDR, kind of like an improved version of EDR called extended detection and response. Okay, then physical security. We have to recognize physical security as well, guys. I mean, if our CCTV systems aren't working, and we come in the next day and notice just something like the gates messed up, just something, there may have been an attack that we didn't monitor, right? So just understanding and having that situational awareness of physical security breaches. Okay, a brute force attack. So a brute force attack is attempting to gain access to a system by systematically trying every possible combination of username or password. So it's time consuming. It's often automated though. There's programs that just run brute force attacks. And there's a lot of good prevention against it though. And brute force attacks are specific to like passwords too, just to let you know. One user and trying 100 different passwords against that one user. How do we prevent this? Strong password policies. And the easiest way to prevent brute force attacks is account lockouts. If an account locks out after 3 tries, good luck trying to brute force, right? And then of course, always, when we talk about authentication, is multi-factor authentication. So if someone does brute force that password, well, who cares? Because now the user is going to get a notification on their phone that says, are you trying to sign in? They're going to say, no, I'm not. And click no. And now the account is locked out, or that user, that attacker doesn't gain access, right? RFID cloning. So if you have a badging system where you have a card with a little RFID sensor or chip inside that goes to a reader that then authenticates you into a secure area, guess what? Those can be cloned. If you want to do this ever, guys, you can go buy a flipper, and there's lots of YouTube videos on these flipper devices that show you how to do this. But that's what RFID cloning is. Cloning someone's badge so that you get their access. And something that's often overlooked by cybersecurity and just in general is environmental threats. So this is exploiting or causing physical environmental factors to disrupt or damage systems. This could include a change in the temperature, turning off the humidity sensors in our data centers. That's an attack, right? If someone does that, they're slowly eroding our systems. So just make sure you have good physical security, implement environmental monitoring. I've been in data centers where like SNMP monitors like UPS, it monitors sensors or HVAC. So a lot of monitoring. Okay, now let's move on to our next section in Domain 2.4. Okay, continuing on with Domain 2.4, now we're going to go over network attacks. So there's going to be attacks that are more network-based, not system-based or physical like we talked about earlier, or application-based. So the first network attack we're going to talk about is a distributed denial of service attack, or a DDoS attack. This is using some sort of network protocol and overloading that service, right? So DDoS attacks aim to overwhelm a target's resources, making the system unresponsive. DDoS attacks can be attacking TCP, could be attacking an API, could be attacking a DNS server by overloading it with DNS requests. It could be NTP, it could be anything that essentially we have a botnet, a system that is maybe doing some IP spoofing and sending all these TCP streams, all this network requests to a service or server and overwhelming it. Now remember, that could be a TCP SYN flood attack. It could be DNS. It could be APIs. Whatever the case may be, essentially DDoS at the end of the day, no matter how we conduct it, whether it's amplified or reflected like what you see on the screen, we're overwhelming a resource. We're overwhelming a network service or server and essentially not making it available to the legitimate traffic. So the two types, amplified DDoS. So this is when attackers exploit the functionality of OpenDNS, NTP, or other servers to magnify the attack traffic directed at the victim. We have reflected DDoS. This is where the attacker sends requests to a third-party server with a spoofed IP address that matches the targets, causing the server to send the response to the target instead of the attacker. So this is just like almost like redirecting, right? Redirecting traffic, but it's a denial of service attack. Most, like, not gonna say most popular, the one you always learn about is like SYN flood attack, where you have a botnet. That's what I have up here, a botnet that's controlled by a CNC server. You have all these bots located around the world, and they start sending TCP connection messages. It's called SYN flags, but they don't ever respond to them, and it's just overwhelming that server. So then legitimate traffic can't have the ability to start their TCP session. Okay, DNS attack. So DNS, what is DNS? So that stands for the domain name system. It does something called host name to IP address resolution. As we know, computers talk via IP. They don't talk like us, like humans, where I say google.com, my computer doesn't know that. It needs to have a destination IP address to build that IP packet. So DNS is the network service, or really the internet service, right? That does that for us, does the host name to IP address resolution. So when I type in google.com, I do a DNS request to like my local DNS resolver. It has in there cached what the IP address of Google is. It delivers that back to me, and then that IP address is what we use to build our packet and put that as a destination IP address in layer 3 header, and then off we go to our destination. So obviously with a protocol that's used for all transmissions in the internet that is needed, it's going to be attacked. So types of DNS attacks, DNS spoofing or poisoning. This is where attackers insert corrupt DNS data into the cache of a DNS resolver, causing it to return an incorrect IP address and redirect traffic to a malicious site. So just putting in bad records in that DNS server. An A record, that's the basic DNS record that actually does the host name to IP address resolution. You could put in bad A records for google.com and redirects you to a bad site. DNS tunneling. So this is where malicious data is encapsulated in DNS queries and responses, allowing data exfiltration. So imagine, DNS on the network is always going to be allowed. You're never going to deny DNS traffic on a firewall. And I don't know when you would. I don't know a scenario where you would, right? So imagine we're trying to do data exfiltration and not get caught. And instead of using the traditional ports for our command and control server to do like an IRC chat, we're a bot exfiltrating data, we hide in DNS. We try to hide within the DNS. And any monitoring, any firewall looking at that, or any monitoring service looking at our packet is just going to say, oh, it's a DNS. So DNS tunneling. Then DNS hijacking. This is where attackers take control of that DNS server and change DNS records. So similar to DNS spoofing, but this is taking control, right? Getting access to that DNS server. Okay, wireless attacks. So what kind of wireless attacks do we have to be aware of? Now, obviously, we talked about Wi-Fi protection and how we encrypt so we don't have like man-in-the-middle attacks. But what are actually specific wireless attacks beyond that, just breaking encryption, right? So evil twin. So this is where an attacker sets up a rogue Wi-Fi access point with the same SSID and has a stronger signal, and your devices automatically connect to that one because maybe it's a known SSID. So we connect to that evil twin that's broadcasting the same SSID we would connect to, but now it's redirecting our traffic for us, doing packet captures, right? So tricking that user connecting to it, and then it intercepts your data. We have something called war driving. So this is where attackers search for wireless networks and try to find open Wi-Fi and then use that, maybe to run attacks from. So then it looks like, oh, the ISP sees you're torrenting from this Wi-Fi that isn't yours, so it makes you safe. Or it's just unprotected Wi-Fi and you're stealing data from it, right? And then WPA or WEP encryption cracking. So this is where we find Wi-Fi that's using that older standards of encryption, and we crack it, and we get access to that data coming across. An on-path attack. So on-path attack is really anything. You see the three we have up here. Is anything where an attacker has to sit in direct path of the user traffic, right? So like DNS poisoning, that doesn't have to sit in path of the DNS server from all the users, right? But an on-path attack says, no, if we're considering it an on-path attack, you have to sit right in that data path. So some examples. man in the middle. So this is where an attacker secretly relays and possibly alters communication between two parties. Session hijacking. This is where the attacker takes control of a user session after successfully obtaining or generating an authenticated session ID. SSL stripping. This is where an attacker downgrades an HTTPS connection to an unencrypted HTTP connection and enabling the interception of data. All these you have to sit on path, right in the direct flow of that traffic. Then another network attack we're going to talk about is credential replay. So credential replay involves capturing and reusing credentials to gain unauthorized access to systems. So credentials are captured using whatever technique you want, phishing, keylogging, sniffing the network traffic, and then replaying it, right? Capturing those credentials that are reused by the attacker to authenticate to a system as if they were a legitimate user. How do we stop that? Always multi-factor, always encrypted, right? One-time credentials. So that's how we stop a credential replay. Okay, now moving on to our last section in Domain 2.4. Okay, now moving on to finish up Domain 2.4. Now we're going to go over our application attacks, cryptographic attacks, and password attacks. Okay, so again, I know it gets a little repetitive. We've been over injection attacks. I think this will be the 4th time just in this video, but this is what it wants us to know about. All the different types of injection attacks. So injection attacks involve inserting malicious code into a program or query that interprets it as part of the command or query. So adding SQL into an input field for your username, and then it recognizes that as SQL. So we have SQL injection, malicious SQL statements that are inserted into a entry field for execution. We have command injection. So this is like running a bash script, right, on a web application that's running on a Linux server. We have LDAP injection. So malicious LDAP statements that are inserted into a web application to modify LDAP statements. LDAP, the lightweight directory access protocol that's used in directory services like Active Directory. Okay, again, talking about buffer overflow. So buffer overflow occurs when a program writes more data to a buffer than it is designed to hold. We've gone through this, so I'm gonna, replay attacks. So replay attacks involve the interception and retransmission of a valid data transmission, often to gain unauthorized access or perform an unauthorized operation. Kind of like we just talked about in the previous section, like a credential replay, but this is just more like broad, just a replay attack. Capture data, replay it, try to get access to something. Privilege escalation. So privilege escalation is something new we're going to talk about. Privilege escalation involves gaining elevated access to resources that are normally protected from an application or user. So pretty much it's, okay, I get guest access or I get standard user access, and somehow I get permissions to go to the admin level. So we have 2 types here. Vertical privilege escalation. This is where attackers gain a higher level of privilege, often by exploiting a vulnerability in software. We have horizontal privilege escalation. This is where attackers expand their access to resources at the same level. So maybe they already have some level of privilege. It's like a database server or like a network switch, but now we're expanding our user account to get access to other things. So mitigation, regularly patching and updating systems, always employing the principle of least privilege, and then monitoring for unusual activity. Forgery attacks. So forgery involves creating a fake document, digital signature, or other imitations of objects of value to deceive others. So we have document forgery, creating or modifying documents to deceive individuals. Digital signature forgery. So actually tampering with or fabricating a digital signature to create the illusion of authenticity. So maybe we're not checking those digital signatures as well as we could, and we just see one's there and boom, we trust it. So countermeasures, certificate-based authentication, always having PKI involved in our digital signature verification. Watermarking is another way to prevent forgery in like documents. Okay, directory traversal, a new attack we're going to talk about as well. So directory traversal involves sending a URL request to get access deeper or to a different section of that web server. Because a Linux web server, right? Yes, it's going to have the Apache web service running or an Nginx web service running. It's going to host all your files that you're doing the HTTP request, to get. But in that Linux web server is also all the other things that come with Linux, like a password file called the shadow file, like your username file called the passwd file that sits in the etc folder. So what directory traversal attempts to do is how we would typically navigate through our Linux machines, right? Change directory ... to go up a level. It's going to try to do that in the URL request to get access to sensitive files like our username file here. So Attackers manipulate variables referencing files with the .. sequence and similar methods to traverse directories normally. The goal is to access restricted files. It allows attackers through a URL request, through an HTTP request, to get access to those files and navigate throughout the system, right? So mitigation obviously is input validation. Always with these web-based attacks, it's going to be some sort of input validation, implementing user permission checks, and then, employing what's called chroot jails or similar sandboxing techniques can mitigate directory traversal attacks, just more segmenting the actual web service in that Linux server, right? Okay, cryptographic attacks, a downgrade attack. So downgrade attacks force systems to abandon higher security protocols in favor of older, less secure versions. So think of like our image here, a man-in-the-middle attack, looking at TLS and downgrading it to SSL. Now, this is just like an example, right? So attackers force systems to revert to older protocols of known vulnerabilities. So that's saying instead of even it being a man in the middle, just us enforcing that web server to use SSL. And then we can decrypt, right? Then we can do actual packet captures and look inside the actual application data. So mitigation, never use outdated protocols, right? Enforce strong cipher suites and implement protocol integrity checks. Okay, collisions. So a collision is not necessarily like maybe an attack that's done, something that could happen when we use older hash values. So a collision is when we use a hash value on two separate input fields, so two separate pieces of original data, and let's say we run an older hashing algorithm like MD5, and what we should get is two different message digests and checksums. We get the same one. That's a collision. So an attacker finds two different inputs that produce the same hash output, undermining the actual integrity, so it won't allow us to. When this happens, it impacts digital signatures. It impacts our ability to actually check the integrity. So how do we prevent against collisions from happening? Use strong algorithms, right? So use SHA. Don't use MD5 or those older, antiquated, outdated hashing algorithms. Okay, a birthday attack. So a birthday attack exploits the mathematics behind, it's quite a definition here, exploits the mathematics behind the probability theory of the birthday problem in cryptographic arena to find collisions in hash functions. Okay, what this is really talking about, it's finding two different inputs that produce the same hash output more easily than brute force searching would. So essentially it's us like having like all these hashes that correlate to like well-known passwords or things like that, right? So that's what a birthday attack is, just pretty much manipulating the hash. So mitigation is employing hash functions with larger hash values, increasing the difficulty of finding collisions, and understanding the limitations of hash functions are key to mitigating birthday attacks. Okay, now moving on to password attacks. So password spraying. So password spraying is taking a well-known password and sending it to multiple different users. A little different than brute force attack, which will take a single user and try multiple different iterations of brute forcing a password. So it's low and slow. It uses common passwords, and really the best mitigation is always going to be account lockouts, strong password policies, and multi-factor authentication. This image here, if you can memorize this is the best way to describe password spraying. The same password used against multiple users. And then brute force, this is trying multiple different combinations for passwords against one user. So we're just attacking that one user. And the protection mitigations are the same, guys. Complex passwords. Account lockout policies would fix this immediately, right? If we had account lockouts, it would have stopped them after this third, fourth, or fifth attempt, however we set it up. Okay, so that was domain 2.4. Now let's finish up domain 2 by going over domain 2.5. Okay, now to finish up this crash course going over domain 2. So domain 2.5, this is going to cover the purpose of mitigation techniques used to secure the enterprise. And in this section, we're going to go over segmentation, access control, and least privilege. Okay, so segmentation. This involves dividing a network into smaller parts to control flow and access. So whether or not this is in a traditional network environment, so we're using VLANs, router on a stick, and then using those VLANs that correlate to subnets, and those subnets correlate to an organizational unit in which we apply group policy, or this is in the cloud where we have micro-segmentation for our microservices doing east to west filtering. Segmentation is always going to be part of enhancing our security just for a lot of reasons. It could be compliance, to apply different policies in different areas. What else? Improve performance, right? Limits network congestion, and also just simplifies the management for us. If we put all of our VoIP systems and printers in its own VLAN, we know the printers are always gonna be part of this IP address. It kind of helps us with management, our policies, our traffic flows, and targeted security policies. It also could be part of compliance. Like PCI compliance says that all your point of sales and your ATM machines must be segmented. Okay, access control. So access control ensures that only authorized users or systems can view, modify, or utilize resources in a computing environment. So this is setting permissions, setting actual like access, who can and can't enter this room, who can and can't even access this file. It establishes user accountability by tracking and logging access, aiding in auditing and compliance. We can also have dynamic control over access. What that means is using different attributes, using context, using a large learning model to build a user behavior baseline or user baseline on where our users access things from. And if it's typically accessed from Phoenix, where they're logging into systems, and we see a login attempt in Brazil, that gives us some context that may be an attack, right? So that's our access control. And ACL. ACL dealing with the network. ACLs are a set of rules that control network traffic and limit access to resources based on policies. So your firewalls work by ACLs. Whether it's a firewall in the cloud or an on-prem hardware-based firewall, there's going to be ACLs with their different access control entries that permit and deny traffic. ACLs can be layer 3, layer 4 base, or we can have more fine-grained ACLs that are part of our next generation firewall offerings that do like deep packet inspection, layer 7. Okay, and then permissions. So permissions are settings that determine the level of access or control a user or system has over resources like files, directories, or devices. Pictured here is the ls-l command, which shows us the permissions in Linux. So we see the D there represents a directory, the rest are files, and it shows the read, write, and execute access. Okay, an allow list. So an application allow list is a way to determine what applications can or cannot be installed. And this is how we set it up. So an allow list involves specifying a list of approved applications, sometimes called a whitelist as well. Essentially, this is an implicit deny. So in our application allow list or whitelist, we deny everything. And then it's up to us as the cybersecurity team, the IT team, to go in one by one and put approved applications on that list. So it's a lot more locked down, a lot more secure. And if you want to add a software to the application allow list, users have to put together paperwork, reasoning, we have to go through vetting and testing, and it allows us to have more restrictive control over what gets installed on our environment. Okay, isolation. So isolation in cybersecurity refers to the practice of separating resources or processes to prevent them from affecting each other. So different than just regular segmentation, where segmentation, you can still have IP reachability everywhere. But with isolation, it's like, no, we're isolating this service to this device or to this subnet. Or computers, we're isolating you to the fact that only you in this VLAN can use like port 445, the simple message block protocol or server message block protocol. Good, the acronym actually is. But that's isolation. This is also done in incident response. When we actually want to contain a threat from leaving a network or from leaving a device, we can actually isolate the single device or subnet. And then, of course, patching. So patching involves the application of updates or software to fix vulnerabilities. So Microsoft, Patch Tuesday. Patches come out all the time for our major operating systems, but we also have patches for our third-party apps that get installed on our operating systems. So make sure that as an organization, you have some sort of patch management system that covers all things to reduce that attack surface and enhance your security and ensures that systems are up to date for those exploits and vulnerabilities so we don't have them. Okay, then monitoring, another concept in cybersecurity that we'll touch on a lot in this Security Plus crash course. So monitoring in cybersecurity involves the continuous observation of systems, networks, and applications to detect and respond to anomalies. So many different ways we can monitor. We can have an IDS system. We could have threat detection enabled on firewalls. We could have user baselines created that are created using large learning machine models, LLMs, large learning models. We could have something like a SIEM appliance and security information event management appliance that's collecting and aggregating all the logs, all the big data, and does real-time monitoring for us. You see Splunk on the screen. Those are Splunk dashboards that are doing monitoring for us. Monitoring may be something that we need to be in compliance with certain regulations that we have to conform to. Okay, awesome. Now let's go over our last section of Domain 2.5. Okay, so last section in this crash course covering Domain 2 of Security Plus. So now we're going to go over configuration enforcement and hardening techniques. Okay, so configuration enforcement. This ensures that systems and software adhere to defined security policies and baselines. And now this could be based off frameworks, based off compliance. We could say, hey, we want to follow the CIS, Center for Internet Security, cybersecurity framework, or we want to follow the NIST cybersecurity or risk management framework. And so we enforce that configuration. We have some sort of standardization on our network and in our enterprise that says this is our security baseline. This could also help us automate it. So if we know what we want to be in compliance with, this helps us build those playbooks and scripts and baseline images that are in compliance with this framework that we're modeling our enterprise after. Decommissioning. So decommissioning is the process of securely removing and disposing of hardware, software, or data. This is part of our lifecycle management, right? How do we decommission? If we're getting rid of solid-state drives, we're not going to be able to degauss them because degaussing doesn't work against solid-state. We have to shred them. What about archiving data? What if it's just software? Instead of actually just, destroying hardware, what if we have to decommission some sort of software? How do we archive it? How do we get rid of that? Resource optimization too. Maybe just as part of us keeping free space, we have a decommissioning process that says, hey, if a file or data hasn't been used in a year, it goes through our decommissioning process. Hardening techniques. So we talked about hardening this whole section, but we want to reiterate it again, right, in Domain 2. So hardening techniques at a high level are just any proactive measure to reduce the attack surface of a network, of your infrastructure, or a single device. So it's surface reduction, it's security enhancement, and it's always an ongoing process. We always want to continually harden based off changing security landscapes and threats. So, how do we harden? Installation and endpoint protection. So endpoint protection involves the deployment of any security software to our endpoints, that's servers, workstation, laptops, mobile devices, to prevent, monitor, and protect our systems, and also stop unauthorized access. So threat prevention. Our endpoint detection or protection, should have threat prevention. It should ensure system integrity, so ensures that endpoints are not compromised. And if we're doing some sort of endpoint protection in an enterprise, we want a way to centrally manage that as well. Allow us to deploy updates to our McAfee anti-malware software that's installed on all of our endpoints. So we want some sort of centralized management. Host-based firewalls. So host-based firewalls, they do the same thing as your network firewalls. It's just not on path, right? It's not filtering for the entire network, just your host. A lot of times this comes standard with your antivirus, anti-malware software, or like your EDR protection. But a host-based firewall is a software application that monitors, controls incoming and outgoing network traffic just for an individual host. Microsoft Defender is something that comes standard now, right? I'm on a MacBook, so I can't bring up Windows Defender, Microsoft Defender, but it's just host-based firewall. It does the same thing, but typically it does layer 7 as well, right? It can do like your application whitelisting as well for you. But it also could just be layer 4, layer 3 filtering as well. And then a host-based intrusion prevention system does the same thing any IPS system does. It monitors, it detects, and it also prevents. So it actually can take action against something. So it provides real-time protection. You can enable, again, that machine learning on it to create user baselines and then protect against something that deviates from that baseline. Disabling ports and protocols, something we've talked about, I think, for the 3rd time now, but this is a part of hardening, disabling unused ports or protocols. And then, of course, for the 3rd time again, changing defaults on your systems to reduce your attack surface. And then removal of unnecessary software. So if you don't use it, lose it, right? It's like an age-old saying. If we don't use it, it's just another increase to our attack surface. Get rid of that software. Okay, so that is it, guys. We had just finished up Domain 2 in our Security Plus crash course. I kept it under 2 hours. It's a crash course, right? So yes, we went a little fast, but if you stayed along for the whole ride, thank you for viewing. Make sure you like and subscribe, and I'll see you in our Domain 3 crash course. And actually, at the end of this video is going to be questions. So I did all this outro, but we're going to add questions too. Awesome. What's going on, everybody? My name is Johnny Bannon, the networking guru, and in today's video, we're going to be covering 70 Security Plus questions for Domain 2. This is the brand new Security Plus exam, SY0-701. SY0-701 that we're going to be covering. Make sure you like, subscribe, share this content with your friends. Now, let's go ahead and jump right into it. Let's get my face out of here. And in today's video, we're going to be using our custom learning management system from trepatech.com that has the 70 Domain 2 questions. If you're interested in purchasing this software, check the link in the description below. But let's go ahead and jump right into it. So I'm going to come to my exams here. I'm going to search Domain 2. And we're going to go ahead and get started. Okay, let me zoom in here so we can see it clear on the screen. Not that much. Maybe right there is good. And we're going to jump right into it. So question 1. A security analyst discovers that an organization's web server is configured to use outdated cryptographic ciphers, making it vulnerable to attacks that can decrypt encrypted communications. What type of vulnerability does this scenario illustrate? It's just outdated cryptographic ciphers, so cryptographic misconfiguration is what we're going to go with here. So essentially what we're saying here, it's using weak ciphers is really what this question is trying to, the point it's trying to get across is that it's using a weak cipher. So we consider that cryptographic misconfiguration. And when those settings are used, you know, it could fall victim to attacks, okay? Question 2. Which of the following best describes an external threat actor with extensive resources, advanced techniques, and a high level of sophistication? So this would be, I would call this an advanced persistent threat, but in the Security Plus SY0-701 exam, they call this a nation-state threat, which APTs are usually sponsored by nation-states, so I'm not going to say it's completely incorrect, but that's what the Security Plus exam says, nation-states. Pause the video if you'd like to read the explanation. Question 3. A user receives a phone call from someone claiming to be a representative from their bank. The caller insists that there has been suspicious activity on the account and requests the user's account number and security PIN for verification. What type of attack vector is being used? So it's a phone call. This is a social engineering attack over a VoIP phone. So this is going to be vishing, voice call phishing. Now on the exam, they won't call it voice call phishing, it'll just be vishing, but I kind of like this answer. It explains that, hey, this is a phishing attempt, but instead of using email, we're using a phone. So vishing. Pause the video if you'd like to read the explanation. Question 4. An attacker generates two different files that produce the same cryptographic hash value, allowing them to forge a digital signature. What type of cryptographic attack does this scenario describe? So essentially what's happened here is that, well, when we take a hash of two separate values, we should create a unique hash for both. If you get the same hash from two different original inputs, that's called a collision. So a collision just happened. So we're going to go with a collision attack. And like older hashes are vulnerable to this, like MD5. So upgraded ones like SHA, 256, 384, 512 is what we prefer. Pause the video if you'd like to read the explanation. Question 5. A user receives an email that appears to be from their company's IT department, instructing them to reset their password through a provided link. The link directs them to a fake login page that captures their credentials. What type of attack vector is being used? So this would be like a credential harvesting attack, but it's asking what the attack vector is. It's email. It says it right there. Email is the way they're trying to that's the vector. That's how they're getting to the victim. It's through email. Pause the video if you'd like to read the explanation. Question 6. An attacker is able to intercept network traffic between a public Wi-Fi hotspot and connected users, capturing sensitive data such as login credentials. Which security risks does this scenario best illustrate? So they're capturing something over a wireless network. So this is unsecure wireless network. So this is a public Wi-Fi that users are not using a VPN or whatever the case may be. They're able to capture sensitive data from those users because it's a public access point that probably doesn't do WPA2, WPA3. Pause the video if you'd like to read the explanation. Question 7. An attacker exploits a vulnerability in an application by sending more data to a memory buffer than it can handle, causing the program to overwrite adjacent memory locations. This can lead to crashes or arbitrary code execution. What type of vulnerability is this? So they're exploiting RAM, the memory, and they're saying that they're sending more data than a memory buffer, like a section of that memory can handle. So we're going to go with buffer overflow here. And let's see what it says. Yep, that is buffer overflow. Pause the video if you'd like to read the explanation. Question 8. A data center experiences overheating due to a malfunctioning cooling system, leading to system shutdowns and potential hardware damage. This incident is classified as which type of security threat? So this is dealing with the environment. This is dealing with something that it's not necessarily an attack, or it's not necessarily someone coming in and, destroying the HVAC. This is, well, I guess that could happen. I guess what I'm trying to say here is that this is environmental, right? There's not something technical that is happening. This is in the environment. So we're going to go with C, an environmental attack. Pause the video if you'd like to read the explanation. Question 9. An attacker sends a specially crafted HTTP request to a web server that includes a URL path containing sequences like this, // // password, trying to get access to the username file in the etc directory of a web server, Linux, allowing them to access restricted system files. What type of attack does this describe? This is called directory traversal. So sending an HTTP request, trying to get to files that are not, that shouldn't be being exposed to the internet, because it's a web server, right? So these files live in Linux web servers. It's a directory traversal attack. Question 10. An attacker exploits a vulnerability in a hypervisor, allowing them to break out of a guest virtual machine and execute commands on the host system. This could allow them to compromise other VMs running on the same host. What type of vulnerability does this describe? So that's virtual machine escape, right? It's kind of, these other answers don't really make sense. It's someone getting out of the virtual machine and getting access to that hypervisor. Pause the video if you'd like to read the explanation. Question 11. A developer writes an application that checks a file's access permissions before opening it. However, an attacker quickly replaces the file with a malicious one between the time the check is performed and the time the file is accessed. What type of vulnerability is being exploited? So it's dealing with timing, and essentially going through iteratively, right, sequentially. It's messing up the sequence. We're going to go with C here. Time of check, time of use. To read the explanation, TOC/TOU race conditions occur when an application checks a resource at one point in time but uses it at a later time, allowing an attacker to alter the resource between these two operations. So that's called a race condition, but it's also like, on the exam objectives, they call it a time of check, time of use attack. Question 12. A security analyst discovers that a malicious program is running on a workstation, capturing keystrokes and sending the collected data to an external server. The infected user has reported an unusual account activity and unauthorized transactions. What type of malware is responsible for this attack? So it's capturing keystrokes. That's the key thing here. So it's going to be a keylogger. And typically keyloggers do come with some sort of data exfiltration with it, which is this right here, sending the collected data to an external server, which could be like a command and control server, or really just a malicious actor. Pause the video if you'd like to read the explanation. Question 13. A security analyst notices that users are being redirected to a fake login page when trying to access the company's website. Upon investigation, they find that an attacker has manipulated DNS records to resolve domain requests to a malicious server. What type of attack is this? So I think this accurately describes DNS poisoning, where we're like changing the A records in there to do bad, resolutions to our DNS requests, saying, hey, that URL, that domain name actually belongs to this IP, and it's some blacklisted IP in Russia or China. That's going to be DNS poisoning. Question 14. A security administrator discovers that an attacker has exploited a vulnerability to hypervisor, allowing them to break out of a guest virtual machine and execute commands on the host system. I think it's like a little repeat one. I'll make sure to jot that down. Question 15. An attacker gains access to a low-privileged user account and exploits a vulnerability to execute commands with administrative privileges. Which type of attack has occurred? So privilege escalation, kind of in the name, in the question there, they used just a user account, and they exploited a vulnerability which allows them to get higher permissions. So that's a privilege escalation attack. Question 16. Which of the following best describes a key security challenge when using client-based security software compared to agentless security solutions? So client-based security software, that's where it actually gets installed in the OS, and it uses that, or the host system, whatever, your laptop, your desktop. And it actually uses that desktop's resources, or that laptop's resources, to include storage and compute, and could really slow down your system. So a key security challenge, though, is, availability is security. So if it slows something down, that is something that as cybersecurity professionals, we have to think about, how our users function in our enterprise. Are we being a hindrance to them? That does, something we should think about. But with agentless software, that's more just reaching out on the network, right? Reaching out from a central server, kind of connecting to these endpoints, these hosts we're scanning or we're monitoring and managing. And it's not actually using that endpoint's compute resources. So I'm going to go with B. Client-based solutions require software to be installed on each endpoint. All right, there we go. We're correct. Question 17. A security team discovers that an embedded system in a critical infrastructure device is vulnerable to remote exploits due to outdated software that cannot be updated. The device manufacturer no longer provides updates, but replacing the hardware is not immediately feasible. What type of vulnerability is this? It's end of life. So that device, whatever it is, let me see this. Okay, let's break this down. This is saying that it's firmware vulnerabilities. I guess, okay. Yeah, this is saying exactly what the... Okay, let's reread this. Security team discovers that an embedded system in a critical infrastructure device is vulnerable to remote exploits due to outdated software that cannot be patched. So the manufacturer no longer provides updates. So that is like an end-of-life, end-of-sale problem. It's really end-of-life because you could be EOS and they won't sell you the hardware, but they still may provide like updates for the next 2 years. They may just, take it off the shelf, the vendor. But an embedded system in a critical... The actual embedded system is what we're worried about, and that has the exploit that can't be patched. So what type of vulnerability is this? I can see where we're getting B from. Firmware vulnerabilities. Let's see what the explanations say. Yeah, this one is kind of... I don't know if I completely agree with it. I think it is an end of life because we can't... Well, the problem is that it's end of life, but the actual vulnerability could be in the firmware, but it doesn't really say that. It just says embedded system. Embedded systems could have real-time operating systems on it, so it's not clear that it's firmware. I think I'm going to go readjust this after this video. That's the great thing about recording, though. I can edit, but I think I'll leave this in here. I think I would actually go with C here. But is end of life really a vulnerability? I wouldn't consider it an actual vulnerability. This one's tough. I think B and C are both good answers. I don't know what CompTIA actually would think about this question. Let me pause the video. I just wouldn't confirm with our AI overlords, did some additional research, and I think this is wrong. It is C. This is end-of-life vulnerability, because you don't know if it's actually firmware, right? Let's redo this real quick. Okay, it won't let me make the change. That's okay. But that one I would say is C. Okay, guys, let's move on. I'm going to have a missed question now at the end of all of these. That's okay. Question 18. A security team implements a policy requiring all company devices to have endpoint protection software installed, host-based firewalls enabled, and unnecessary services disabled. What security practice this policy enforce? So we're not talking about what are we actually installing, what kind of software is this we should implement, EDR, XDR, DLP, whatever. This is saying what kind of best practice is this? This is hardening. We're hardening our endpoints by implementing all these things. Question 19. A security engineer segments an enterprise network into different zones, such as public, internal, and sensitive data zones, to reduce the attack surface and limit lateral movement in case of a breach. What is the primary security benefit of this approach? So it's isolating the systems, right? We have this granularity now in our actual networks that we say, hey, if we get a worm on this little network segment, well, potentially our sensitive network segments they're not vulnerable to that. So maybe we have policy assigned to those network zones. Or, things that, a firewall, whatever, things that are filtering between those zones. Question 20. A hacker calls an employee pretending to be from the IT department. The hacker claims there is an urgent issue with the employee's account and asks for their login credentials to verify access. Which type of social engineering attack is occurring? So again, it's over the phone, right? Yeah, calls. I wouldn't say brand impersonation. We're going to go with vishing here. Because it's over the phone, voice. Question 21. An attacker registers a website domain similar to a legitimate online banking site, but with a minor misspelling. Look at that. A little misspelling there. The attacker then uses the site to steal user login credentials. Which type of attack is best described? This one best describes typo squatting, where you just register a domain name that's very similar, and then, you're hoping that users make a mistake and go to your malicious one here. Question 22. A network administrator configures a firewall to allow only HTTP and HTTPS traffic to a public web server while blocking older types of connections. What security mechanism is being used in this scenario? Security mechanism? So in firewall, that's access control list. Let's see. Yep. So access control lists have access control entries that permit or deny and filter layer 3, layer 4 traffic on a traditional firewall. Question 23. An attacker exploits an undiscovered vulnerability in a mobile operating system, allowing them to remotely execute code before a security patch is available. What type of vulnerability is being exploited? So it's 0 day, right? There's no patch for something. It's a 0 day attack because there's no fix. Question 24. An attacker attempts to compromise multiple user accounts by trying a small set of commonly used passwords across many different accounts, avoiding account lockout. So, they're going through users trying all these passwords, okay? What type of attack is this? So it's not brute force, because I think brute force is like one user and trying thousands of passwords against that one user. It's not a birthday attack. This is a password spraying attack. This is saying, hey, we have all this list of users, and we're going to spray this password against all these different users, and hopefully one hits, like a common password. So we're going to go with C. Password spraying attack. Question 25. Which of the following best describes an employee who circumvents IT policies by using unauthorized cloud services or personal devices to perform work, potentially exposing sensitive data? That's going to be shadow IT. So that's going to be you taking IT into your own hands. Not necessarily malicious. Question 26. A user receives an MMS message containing an image that, when viewed, executes a hidden exploit in the image processing library, allowing the attacker to gain remote access to the device. What type of attack is this? They're trying to fool us here. So the attack vector is, a message. You receiving a message. But there's an exploit hidden in an image that you may download. So the actual attack that's happening is image-based attack, and they're using this vector SMS to deliver it. but they're saying what type of attack is that? That's an image-based attack in this very specific scenario. Question 27. I mean, it was kind of both, right? But I think it's trying to get you like, oh, that would be a vector. That's how they accomplish the social engineering. All right, moving on. Question 27. An employee is fired from a company and later uses their retained access credentials to delete critical business data and disrupt operations. What is the most likely motivation behind this attack? Revenge, right? If that employee was fired and now they want to, hack your networks, bring things down, it's just revenge-based attack. Question 28. And we stop that by doing audits, right? Account audits and doing proper offboarding. Question 28. A security analyst discovers that a web application allows users to input data in a form field without proper validation. An attacker inputs a specially crafted SQL statement that retrieves all user account details from the database. What type of attack is this? So that's a SQL injection attack. But to prevent this would be something called input validation or parameterized queries. That's how we would prevent this attack. Question 29. A security administrator notices that a single user account has multiple login attempts for different geographic locations within a short period of time. One from the United States, another from Europe within minutes. What type of security indicator does this represent? Impossible travel. It's not possible for our user to be logging in at, the same time from even a mile distance, right? So impossible travel. That's having that good contextual awareness too, and like our policy enforcement points, and whoever's making the decision to authenticate, that's good contextual awareness. Question 30. A security analyst observes that an attacker is forcing a web server to use an older, weaker version of TLS, making it vulnerable to known exploits. What type of attack is this? It's a downgrade attack. Forcing the TLS to an older version to then exploit. That is called a downgrade attack. Question 31. An organization enforces a security policy where only pre-approved software applications can be installed and executed on company systems, preventing unauthorized or malicious software from running. Which security control is being applied? Pre-approved? So that's going to be an application allow list, sometimes called a whitelist, that pretty much has an implicit deny, and then you have to get it, as individual software applications approved, added to that list to then be able to be installed on the network. So that's an application allow list. Question 32. A cybersecurity team deploys a security solution that continuously analyzes system and network activity to detect suspicious behavior, unauthorized access attempts, and potential data exfiltration. Which mitigation technique is being used? Continuously analyzes systems. It's monitoring, right? It says it right there, to detect suspicious. That's a monitoring. We're doing monitoring in this scenario. That could be with an IDS, firewall, EDR, XDR. Question 33. A software provider unknowingly distributes a malicious update that contains a hidden backdoor, allowing attackers to gain remote access to client systems. This compromise affects thousands of organizations. What type of attack does this represent? So since it's a provider, it's someone supplying software or supplying hardware. Well, in this case, just software. But if someone was supplying that and there's something malicious in there that they didn't know about, that means our supply chain is vulnerable. That we're going to integrate this software, this third-party software into our networks, and we didn't know that there was an exploit in there. That's a supply chain attack. Question 34. An IT department reports that a critical business application unexpectedly deletes files on the first day of each quarter. Upon investigation, they find malicious code embedded in the application that triggers based on this schedule. So there's a logic bomb. What type of malware is responsible with logic bomb? It's pretty much if-then statement. If you meet this criteria, then launch this malicious script or malicious software. In this case, deleting files. So that is a logic bomb. Question 35. A user purchases a new laptop and notices that it comes pre-installed with multiple trial software applications that they did not request. These programs consume system resources and slow down performance, but are not inherently malicious. What type of software is this described? This is bloatware. This is, it's add-ons. It's additional plugins that maybe we weren't exactly aware of, but now they're on your system and it's going to slow it down because it's using excess compute. Question 36. A company unknowingly installs a software update that has been tampered with by an attacker. The update includes a backdoor that grants unauthorized access to the system. What type of vulnerability does this represent? It's a malicious update, right? So we updated something, and now that update's been tampered with, and we have some sort of malware on our system. Question 37. A manufacturing company uses hardware components from a supplier that was unknowingly compromised by an APT, Advanced Persistent Threat. The infected components include backdoors that allow remote access to the company's internal network once deployed. What type of attack vector does this represent? So that's a supply chain attack. Remember, it's kind of asking like the same question before. We're getting something from a company, integrating to our network, and we didn't know there was an exploit. That's a supply chain attack. Question 38. A security administrator discovers that a critical business system is running on outdated hardware that is no longer supported by the manufacturer. This system cannot receive updates, making it highly vulnerable to attacks. What type of vulnerability is this scenario describe? That's end-of-life vulnerability. That one's pretty cut and clear. It's EOL. Question 39. A penetration tester discovers that a web application allows users to submit SQL commands in input fields, enabling unauthorized access to databases. Which type of attack is occurring? So this is an injection attack, more specifically a SQL injection, but here our answer is just injection, so that's C, injection attack. We have LDAP injection, other XML injection. It's another another injection attack. Question 40. An attacker scans an organization's network and discovers that an outdated database server is listening on port 3306 with no firewall restrictions. This can allow an attacker to exploit vulnerabilities in the database. What type of threat vector does this scenario represent? So there's a port that it's listening to on 3306. So if we were to make a connection on that port, it would be wide open for us. So that's going to be C, open service ports. Question 41. Which characteristic distinguishes an internal threat actor from an external one? So that's just, are you on the inside? Do you know? So internal threat actor, it's just access to our systems. Doesn't mean they could be more, less sophisticated. It really just depends on, their access. Question 42. An attacker is able to gain access to a secure facility by copying the data from an employee's access badge and writing it to a blank RFID card. This allows them to enter restricted areas without detection. What type of attack does this represent? That's a RFID cloning. We're just literally cloning that radio frequency identifier onto our card. You can do this with like a flipper as well. If you don't know what that is, look it up. Pretty cool. Question 43. Which of the following motivations is most commonly associated with a nation-state actor conducting a cyber attack against a foreign government's defense systems? That's it. Ethical hacking. No, the best answer here is going to be espionage, right? We're just trying to ruin, our adversaries, attack our adversaries. Question 44. An employee plugs in an unknown USB drive found in a parking lot, unknowingly launching a malicious script that installs keylogging software on their workstations. Which type of attack vector does this scenario best describe? That's a removable device. So that's what a USB is. It's a removable device. It's part of like social engineering, kind of, because it's like, oh, it's in your company's parking lot, so it's probably somebody's USB, so it's probably not malicious. Kind of like, almost like pretexting, like, well, it's in a safe area, so it should be safe. But that's a removable device. So it's a removable device attack. That's the most accurate answer here. Question 45. An organization continues to use network routers and industrial control systems that are no longer supported by the manufacturer. These devices contain unpatched security vulnerabilities, making them susceptible to attacks. What type of risks does represent? That's legacy hardware. So legacy systems. The way we protect against this is either upgrade. If we can't upgrade, implement compensating controls like host-based firewalls, segmenting networks, hardening techniques. Question 46. A cloud provider dynamically allocates virtual machines to different customers. A security researcher discovers that residual data from a previous used VM instance is still accessible after the instance is reassigned to a new customer. What type of security risk does this represent? This is describing resource reuse. So just not doing proper like your data lifecycle, getting rid of data remnants, and because you're reusing a resource. So that's going to be A. Question 47. A company deploys network printers and IoT devices using their factory set login credentials. That's a no-no. Shortly after, attackers exploit these devices to gain unauthorized access to the internal network. What is the primary vulnerability in this scenario? It's just leaving it at default credentials. We protect this by doing hardening, segmenting the network, just the basic things. We're buying like off-the-shelf stuff to bring into our network and our enterprise. Question 48. A company's security team discovers that a piece of malware has been secretly embedded in their software updates. The malware remains dormant but is programmed to execute destructive actions if a specific condition is met, such as a certain date or user action. What type of malware does this describe? So again, that's a logic bomb. A Trojan is just a disguise. Rootkit is getting to like the kernel of the system, and virus is just kind of like an overall umbrella term for like malware. This describes a logic bomb because of the timing of it, right? It's logic. Only execute if this condition happens. Question 49. During a routine audit, a security team discovers that certain system logs are missing or incomplete, making it difficult to trace recent security events. What type of malicious activity indicator does this indicate? So, missing logs. So, missing logs, right? That's just pretty much saying like, oh, someone's tampered with this. So we see that logs have been tampered with. It doesn't make sense. Like, the sequence is off. We can assume maybe someone has some privileges that they shouldn't. And they're trying to hide something. And this could be an admin that messed up and wants to hide their tracks, or it could be something malicious as well. Question 50. A cyber criminal group operates a ransomware as a service business, providing malware to less skilled attackers in exchange for a share of their ransom payments. What does this scenario best describe? Sounds like organized crime, right? I wouldn't say high sophistication. Yeah, it's unskilled attackers with high resources and low sophistication. Okay. Let's see the explanation here. I don't know. It's cyber criminal groups. I mean, ransomware as a service, I feel, is pretty sophisticated. But the actual scenario is like, I think C or D could both work. Let's read the explanation. This scenario describes an organized crime group that monetizes cyber attacks or ransomware. They're not as if, okay. No, I think correct. I think that's probably a better answer. Moderate sophistication, right? Because they're not, in CompTIA's terms, highly sophisticated because they're not from nation states. They're not advanced persistent threats. So if I look at the first sentence here, that's what it's asking us to describe, not the end point, right? Which is what they're trying to get to, unskilled attackers. But I don't know. I think kind of a tricky question here. That's okay. I guess I can't always be 100, right? Maybe I'll edit this. Question 51. A hacker group launches a distributed denial of service attack against a financial institution to protest unethical business practices. Which of the following best describes their motivation? So it's a protest. So it's their philosophy. It's their morals, right? This would be called a hacktivist. Question 52. An attacker captures encrypted authentication traffic between a client and a server, then replays the captured credentials to gain unauthorized access to the network. What type of attack is this? Credential replay. Literally, it's in there, right? They're stealing credentials and then replaying them, hoping to initiate that session or to get an authenticated session. Question 53. A company discovers that attackers gain unauthorized access to a network device because they were still using the manufacturer's default password. What hardening technique would have prevented this? This one's easy, just changing the default credentials, and in this case, the default password. So you can't easily look up a product and then on their forums, like, oh yeah, this is the default password. We don't want that in our network. Question 54. A security analyst detects a program running on multiple endpoints that records users' keystrokes and sends the captured data to an external server. Which type of malware is being used? That again is going to be keylogger because it's capturing the keystrokes, capturing data, and sending it off. So that is a keylogger. Spyware is just, that would have been another answer that could be a little confusing. Oh, it's like spying on you, but doesn't specifically log keystrokes. A worm is malware that was self-propagating. Then a logic bomb, we've been over that a few times. That's not described here. Logic bomb is malware that meets a condition and then launches. Question 55. An organization's web server becomes unreachable after an attacker floods it with massive amounts of traffic by exploiting publicly accessible DNS resolvers to amplify the attack. Which type of network attack is occurring? Just as like a subset of DDoS attacks, kind of getting more specifically into the type of DDoS attacks. So we're using public resources to amplify our DDoS attack. So what do you think this is called? Amplified DDoS attack. Question 56. Which of the following threat actors is most likely to have substantial resources, including advanced technical capabilities and long-term strategic objectives, often targeting government entities or critical infrastructure? That's a nation state or an advanced persistent threat. Highly sophisticated, lots of time, lots of resources. Question 57. An organization experiences a cyber attack in which files across multiple systems are encrypted, and a message appears demanding payment in cryptocurrency to restore access. What type of malware attack has likely occurred? So that's ransomware. That's a malware where it takes control of your system or denies you access to your files by doing an encryption. Then a little pop-up comes up that says, pay us 0.01 Bitcoin, and you pay it, and guess what? You're still encrypted, and they ask for 0.02 Bitcoin. To protect against this, like if it happens, make sure you have default backups. Make sure you have good restore points that don't have the malware on there. And of course, in our basic defense in depth, antivirus, don't click on phishing links. Question 58. A penetration tester discovers that a company's website does not sanitize user input in the command section, allowing an attacker to insert a script that executes in the visitor's browser. When users view the comment, their cookies are stolen and sent to the attacker's server. What type of vulnerability is being exploited? That's cross-site scripting. So the first time it's not an ejection attack on this test, that's cross-site scripting. To prevent this, guys, input validation. Input validation is a way to prevent this. Question 59. An attacker compromises an MSP's remote management tool. Ooh, now they got access to so many companies, allowing them to deploy ransomware to multiple clients simultaneously. What makes this type of attack particularly dangerous is, MSPs have direct access to multiple customer networks. So it's a breach on the MSP that leads to breaches to multiple different companies. So we're going to go with A. MSPs have direct access to multiple customer networks. Question 60. An individual with low technical skill follows online tutorials to launch a simple ransom attack against a small business. What type of threat actor does this represent? That's an unskilled attacker. And this is one that's very unique. I like this because a lot of times small businesses, it's sad, they don't have the money or they don't prioritize cybersecurity. And this can happen. Their WordPress site gets exploited and then, it messes up their whole business, their whole livelihood. Sometimes, we used to call it a script kiddie. Now the test says unskilled attacker. They're trying to make cybersecurity more professional. It's not a script kiddie. It's an unskilled attacker. Question 61. A system administrator is retiring outdated servers and ensuring that all sensitive data is securely wiped before disposal. The administrator also removes the devices from network inventories and revokes associated access permissions. What security process is being followed? An actual good decommissioning process that's looking at all the second order effects besides just throwing, taking the hard drive out and throwing it away, taking it off our asset inventories and stuff like that. It's good. That's a good network or system administrator. So that is B, decommissioning. Part of the data lifecycle. Question 62. A security administrator ensures that all company databases store sensitive customer data in a format that renders it unreadable without a decryption key. This practice primarily mitigates which security risk? Unreadable without decryption key. I'm going to go with data exposure, right? We don't want those databases getting exploited and then getting exposed. So I'm going to go with A, data exposure. Question 63. An administrator enforces strict user permissions so that employees only have access to specific files and systems required for their job roles. What security principle is being applied? That's least privilege, which also what's described here is also role-based access control, which is something you implement to follow the principle of least privilege. Only giving users the exact permissions they need so we don't have privilege creep and we don't have, potential insider threats. Question 64. A cybersecurity analyst detects that a server is experiencing unusually high CPU and memory usage, slowing down critical applications. Upon investigation, they find unauthorized crypto mining software running on the system. Which security indicator does this scenario best describe? So how do we find it? What's our indicator? Is high resource consumption. This compute resource is what we're talking about in this scenario. That shouldn't be happening, right? Maybe we have designed our images, our operating systems, our desktops, our users' laptops to say, hey, even if they have 10 Chrome tab opens, we kind of have accounted for this, and we're seeing high spikes at 2 a.m. Why do we have this high resource consumption? So we investigate it, and it's crypto mining software. Question 65. A cloud service provider assigns computing resources dynamically to multiple customers. A researcher remnants, we kind of already did this one, but it's okay. Researcher discovers that remnants of one customer's data are still accessible to another customer due to improper resource deallocation. What type of vulnerability does this scenario illustrate? Or actually, is this resource reuse? Let's see. Yeah, it's a resource reuse vulnerability. C is kind of tricky. It's cloud-based misconfiguration, but that kind of almost implies that we did something. We misconfigured our cloud instance. This is saying the CSP did something wrong. So that's why I'm leaning towards D, resource reuse vulnerability. Question 66. A user downloads an application from an unofficial third-party app store and installs it on their smartphone. The application appears legitimate, but secretly contains malware that steals personal data. What type of security risk does this represent? Don't think it's C. Don't think it's D. It's going to be jailbreaking or sideloading. Unofficial third-party app store. Jailbreaking, let's just see. It's either A or B. I think it's going to be B here. Because sideloading is when an application is installed and it's kind of in the name. It's I got this from a non-compliant store, not the official app store. Jailbreak is when you pretty much unlock your entire phone, right? That's not what's being described here. It's just saying, hey, unauthorized application being installed. We prevent this by implementing MDM, mobile device management, if this is a corporate-owned phone especially, and then doing whitelisting, sandboxing. Question 67. A hospital continues to use outdated Windows XP machines for critical medical equipment. These systems can no longer receive security patches from the vendor, making them highly vulnerable to exploitation. What type of security risk does this scenario illustrate? So B, unsupported systems and applications. Again, it's just an end-of-life system. How do we protect? If we have to use end-of-life, how do we protect against it? Again, it's going to be with compensating controls. Isolating that machine. Putting as much hardening techniques as we can on it. Question 68. A company's employees receive an email that appears to be from the CEO, instructing them to urgently transfer funds to a new corporate account to finalize a business deal. This email address closely resembles the CEO's, but is actually from an attacker. What type of attack does this represent? What type of attack is this? This is going to be business email compromise, actually. Maybe you could think this was whaling, but it's business email compromise because of that key one here. It resembles the CEO's email address. So that means maybe someone actually created a legit email on our domain, and now we're compromised there. Question 69. A security analyst detects multiple failed login attempts from a single IP address, followed by a successful authentication using an administrative account. The login attempts appear to be systematically trying different password combinations. What type of attack is this? That's a brute force attack. We're trying the same password, or trying different passwords over and over and over again on a single account. How do we protect against this? Account lockouts, good auditing of our accounts, and multi-factor authentication. Question 70, last question. A large corporation suffers a data breach after attackers compromise a third-party payroll service provider. gaining access to sensitive employee information. Which supply chain vulnerability does this represent? It's our vendor. Our vendor got compromised. It's not default credentials. It's not a network that's unsecure. And it wasn't an insider threat. Well, maybe it was at the payroll provider, but we don't know that. That's a vendor compromise to us. Alrighty. Thank you guys for viewing this video. If you want access to these practice questions and our whole practice exam dumps, it's over 1,000 questions, click that link in the description below. If you're interested in live virtual training for Security Plus, check out the link in the description below. Thank you for viewing. I'll see you next time we go over Domain 3.